All right. Welcome back, everyone, for the session. And I hope, I think, actually, there's a bit of a problem. Even I'm hearing some kind of static noise, most likely because of the rain affecting the things. So, anyways, I hope things are okay enough for now. So, yeah. I think more or less yesterday, right? I think we all had a nice interactive session as to what we talked about in terms of training these, like what it particularly looks like, right? So training these huge setups, huge systems, right? If I talk about, right? I'll just quickly zap through without wasting much of it, right? Because more or less we understood the context, right? So I hope everyone remembers, right? The very first step, right, into creating these stuff, right? Obviously, you need some kind of a corpus or a big, what you say, um, chunk of data from somewhere, right? In the context. So basically, nothing but you download it from the internet, right? There are many available corpuses and stuff, right? If I talk about, right, through various different sources, and yeah, I think I could not mention yesterday one more thing here, right? So that the model, I mean, if I talk about, right, in the context, right, the model tends to mimic the behavior of the internet, right? So the way things are, right, if I talk about, right, you see the Wikipedia here, right? What I mean to say here is, right, when I talk about Wikipedia as a source, right, because fact is, right, it might have seen, I mean, n number of times this particular page on different things, right? Not a similar topic, but I'm saying, right, you might have seen, right, whenever you search anything, right, you might have seen that it comes directly, like the very first or the second search, right? If I talk about, right, it's always Wikipedia, right? You type anything, right, in the context, right? Maybe if I talk about, let's say, Anaconda, if I talk about, right, as a what you say, snake. Okay, if I say something in those lines, right? You can see here, right? I mean, you will see that as a snapshot, right? I think it's safe to say that I mean, Wikipedia kind of acts like the what do you say, front end of the web, right? Whenever you try to what do you say, look into or search into something, right? If I talk about, right, that gets, I mean, Wikipedia is always the first choice and stuff, right? If I talk about in the context, right? So I think more or less you understand, right, that during the time of extraction of these pages, right? So I told you one of the companies which is doing this great job for all of us, right, creating that publicly usable repo and stuff, if I talk about, right, the common crawler, if I talk about, right? So it is most likely that these pages, right, from Wikipedia have a lot of, what do you say, it is given much more of a preference, right? So if I talk about, so you can think of like there is a segment in the neuron. It's like a big bookshelf, right? If you talking about these giant brains, right? I told you that these are big machines, right? If I talk about math machines, right? So there should be a big dedicated workspace or a dedicated what do you say, matrix, where it just, I mean, it's about very much dedicated to Wikipedia, right? So I think you can understand the context here, right? So I'm just giving you a vivid picture about what we are discussing about here, right? If I talk about, right? So, I mean, that's the whole point of it, right? Whenever you look into any topic, right? That's pretty much goes to Wikipedia in the very first essence, right? If I talk about. So, it is possible that many a times, whatever you see in the output, right? If I talk about, right? You might be tending to see a Wikipedia based output and stuff, right? If I talk about in the context, right? Because we also discussed that these brains initially they are nothing but what you say giant brains who are simulating or like what do you say, dreaming, or maybe what do you say, practicing internet only, right? So it's like that if I talk about in the context, right? So we talked about different corpuses, right, which is superfined, right? Whatever you have extracted from the website, I mean, from different web pages, right, through common crawler, goes through that fine web pipeline, right? We saw that and stuff, right? I hope that's particularly understandable and stuff, right? I hope that's particularly clear. And post that, if I talk about now, the recipe is ready, right? You want, I mean, sorry, the ingredient is ready, if I talk about, and that ingredient goes through the process of tokenization and stuff, right? If I talk about in the context, whatever it has been defined up as, right? So we discussed in detail about how things work out as a byte pair, right? When I talk about, right, we discussed about those, and I told you about these. Core language 100K underscore base, right? You can see there is underscore base here, saying that it is used for base models. Okay. So, by the way, when I talk about, right, there are few different kinds of models. What you turn up after this, right, is called as a base model. Okay. Which is rich in knowledge, right? If I talk about in the context, right? So we'll look into a few more aspects, okay? With a vocabulary size of 100K, if I talk about, then we discussed about few of the examples where we discussed about these few things, right? Wherein you, like we discussed about how characters conversion gets into place, right? So guys, please feel free to stop me, right? Whenever you feel like, I mean, in case you want me to elaborate it a little bit further, right? But I'm just quickly zapping through, right? If I talk about, so most like, I mean, more or less, I think that's particularly understandable by everyone, guys, right? So next thing, if I talk about, is how you teach those machines, right? If I talk about in the context, right? So obviously, it goes through. These things are pretty trivial now, right? We have discussed it since last 10 days to be specific, right? How the internal mechanism works, right? Thanks to Aditya sir and myself, we have gone forth and discussed in detail about all of these things, right? So these are all just pointers, right? Embedding vectors, you have attention, and then it goes to the feed forward layers, right? And then obviously you get a output which is like a probability distribution of over the entire vocabulary, right? I hope that's clear for everyone, right? So these are few things which we discussed about in the context, a step-by-step procedure in the form of what do you say, a few cards and stuff, right? Then you talk about, like I told you, right? The state-of-the-art models nowadays have this more than 8K as the context window and stuff, right? If I talk about, and then we discussed in detail about how it works out, right? In the context about it, right? So, I mean, it's basically a total bit of a probability if I talk about, right? So I think you can understand, right? And that's why you have, what do you say, is context is everything, right? If I talk about, right? Hopefully we all understand this overall idea which we discussed about, right? So it's like as we discussed about, right, a very raw form to say it as, right? It's a giant math machine, right? If I talk about, right, the transformer core and how it works out in the context there, right? So hopefully that's clear for everyone, right? Then the art of generation, wherein I told you, right? You have the pre-training phase, then there's the inference, right? When you you don't train the machine to learn about the weights and stuff, right? You use it, right? Inference is like the using step, right? If I talk about, and very correctly described by Jay sir yesterday also. I think Jay and yesterday he gave a vivid picture when I asked about it, right? So hopefully everyone is clear about the context, right? And then we talked about few of the decoding strategies, right? Or what you can talk about, right? It is good to have greedy approach. Guys, do you remember when are these three things used for? I told you, especially, okay, greedy decoding, when would you like to use it? You remember? In what context would you like to use greedy decoding? याद है किसी को? Anyone?
To identify the next token.
Sir, actually, in fact, greedy decoding, sampling, and top K, everything is doing. the same thing if I talk about, right? But sir, I mean, if I talk about greedy decoding, right? You become greedy, right? The approach is you become greedy. That is okay. Which is the most favorable outcome? You take that. So basically, the
Like
window becomes smaller.
without,
Yeah.
it is like without putting so much effort, I want
Huh.
answer.
Exactly. So yeah,
Then I will
exactly.
go with.
Yeah, you don't have a sea of probabilities. You just see that okay, the one which is the highest probability should be given the next possible stuff, right? Just like how Ankit sir has also mentioned, right? Hopefully that is understandable. Greedy approach, meaning you become greedy or you become like lalach aa gaya and you take that stuff, right? Whatever having the best stuff, right? Whichever is aligning towards you the best. And what does this alignment mean? Which one is having the highest probability is given the next set. So I told you about the problem of this greedy approach, right? If I talk about, right, that you can complete few things, okay? So maybe you have a short passage which you want to write, right? A nice short passage, that's okay. But after some time you will see that because it goes out of it, right? Because the fact is okay, it has the context window, it is predicting, right? If I talk about, right, but you should understand that whatever words should come up next is trying to reduce the vocabulary size, okay? So generally, that's why you talk about in the context of. So if you have a short stuff which you want to go ahead and do, right, use the greedy approach, right? But however, you can go to the next sampling or otherwise. I told you, right? It's basically the temperature, right? If I talk about, right, which adds creativity, right? So I told you, right, you have that probability distribution and they become well aligned. You saw that yesterday, right? They become well aligned, right? If I talk about in the context, right, where you talk about out of those probable stuffs, right? You take some things which are particularly which you want them to be part of the entire, I mean, part of the forthcoming stuff, right? If I talk about, and that will be their contribution as well, okay? And post that, so I think you can understand it adds creativity, right? So we talked about that. Yeah, others, sir, you have raised your hand.
Uh, Sir, you give an example like in which scenarios I understood where it is. It's fast. Greedy decoding is fast.
Uh-huh.
But if you say like if I want a creative thing, then sampling is used. And if I want something which I want fast, like chatbots, is it greedy decoding? Is it like that for different applications? I have to uh,
Uh-huh.
which I need to use.
Yes. So,
I want not able
sir,
to frame the question.
no, I understood, sir. Yeah, actually, sir, you will get more clarity on this when I show you what this actually does, right? If I talk about, I'll actually talk about it, but just to give you a sample idea here, right? If I talk about, the idea is greedy, you understood, right? That's why it's called as a greedy approach, meaning you don't rely on a huge set of probabilities and then you figure out, okay, I have to take this word because this is going to affect the next set of words. You got it, right, sir? In a greedy approach, what you do is very simplistic, straightforward, that whatever gets the highest, I mean, I think you can understand, sir, like, suppose, what do you say? There are two things, right? So suppose there's tea and there is cold drink, right? And maybe for a person like me, right, I don't prefer tea much. I like cold drinks if I talk about, right? So my approach, if the two items were given, right, if I talk about, right, then in that case I would I mean, obviously be whatever is favorable to me, that is cold drink, would be given the first priority in the context, and the rest of the things, right, they come afterwards. You might have seen, sir, in this approach, right? If I talk about, मैं इसमें फिर से जाके आपको दिखाता हूँ एक बार, right? If I talk about, right, you would see, sir, basically greedy approach is nothing but temperature set to very less. Did you get it, sir? You understood,
Okay.
right? Uh-huh. So
Okay.
if I said, yeah, look at this. If I talk about,
So we'll get
come
more
on.
factual answers.
Yeah, you see this, right? So I have reduced the temperature to, you can see, right? I've reduced the temperature to 0.2, right? And can you see visualize gets the highest cup in that, right? Compare it with create, which gets a very less toll, if I talk about, right? You have 97. So I think you can understand when I click or hit on generate, so it will take these entire thing again. Go to predict with the next word, right? If I talk about, right? I don't know whether it works now. I don't know if I talk about. Yeah, you can see, sir, right? So I mean, I'm trying to do that, and you can see and given the next preference, right? If I talk about, right, then I generate again, right? If I talk about, right, you can click on one word at a time, and you can see, sir. Can you see this here? What happened if I take the temperature as 0.2? Can you see this here? Visualize and visualize, right? You see this, right? So what this is what I wanted to tell you, sir, right? If I talk about the greedy approach is okay, that's nice, but fast but repetitive. Yeah, actually it is not this much repetitive which you see here. This is just a what do you say, playground, but you'll see some few words and then again you'll realize what the hell are you doing? You are again repeating the same sentences, just changing the form. That doesn't make sense, right, sir? So I think that's the whole point of the greedy approach, right? So,
Temperature is not deciding which approach is being taken, right?
so exactly. The fact is, when you don't, the idea is, if I talk about the lowest value of temperature is 0.2. Okay. So basically, it's like I'm turning off the knob of temperature. Did you get it, sir? I mean, I don't want temperature to be part of it. Did you get it? Because you can see because obviously the temperature contributes in its own sense, right? But if I talk about what if the idea here is pretty simple that you don't want temperature to contribute to the overall output. Do you get it, sir? That is the whole idea. So the lowest possible value which we can see here is 0.2. If I talk about, right? So in that case, it's like you're basically turning off temperature in this case. You got it, sir, right? So just because the temperature value shows 0.2 doesn't mean that you are sampling. You got it, sir. That's what I meant to say here. You got it, right? So it's like turning off. You see that there is no knob called
But here we are using
greedy
sampling
decode,
based
right?
decoding, right? In this example, this is
Uh-huh.
sampling based decoding, right? This is not
But
greedy.
sir, sir,
No,
the
we
fact
off
here is,
the
yeah,
we
yeah, go
kept the
ahead. You were
temperature
saying.
off, which makes
Uh,
sampling based decoding off.
Sampling based decoding off. Exactly, you're right about it. Yes. And the moment I say sampling based decoding is off, by default it goes to what? Greedy. Do you get it, sir? That's what I am trying to imply
Okay,
here.
okay,
You
okay,
got
okay,
it, sir?
got it.
When you turn that knob off, what is it happening? Basically, going to greedy decoding. So
Greedy
if you
decoding.
have these two knobs, yeah, exactly. If you have these two knobs on, that means greedy decoding is by default turned off. You got it, right, sir?
Got it, got it.
Right? Yeah.
Understood.
So that's the whole idea behind it, right? So the idea is pretty simple. Like if I talk about the temperature should not contribute because the temperature here is, I told you yesterday that there was, I told you a word yesterday, like entropy, right? Entropy is how random you can talk about in the context of it. So randomness is what determines creativity in the context as well, in the context of what we are discussing. Okay. So I hope that other sir, all good?
It's clear, sir. Clear. Got
Okay.
it.
Perfect. Perfect. All right. So sorry, guys. So I think more or less we all understand this, the concept which we are trying to talk about, right? So I think you can understand here, like every word is like a sampled guess from a vast ocean of possibility. So, the whole point here is, guys, right? You don't generally use just this. You generally try to talk about a balance between these two, if I talk about, right? So that's why you have a top K and top P, right? If I talk about. So you take a balance of it so that you talk about in terms of, okay, there is flexibility which you can have for number of variations or the temperature parameter, as well as from how many to pick, right? If I talk about. So I think more or less you can all understand. And I think this is a smart way of doing it, right? You see that there is top P, which says you remember, right? If I talk about, right, the cumulative density or cumulative probability, right? And I think more or less, if you think in terms of maths, right, something having very high probability and a set of values having some of the probabilities, and then you just take one of them, makes sense rather than talking about the ones who come at the bottom. That is an intelligent choice of what you say, taking both the terms in parallelly in the context, right? So if I talk about, that's just to explain the stuff a bit. So hopefully that's particularly understandable. Now, yesterday we moved then again to GPT-2, right, which started the fire basically, right? If I talk about, people thought before that, people thought of like this couldn't be possible, but they made it possible, right? If I talk about, right? So the biggest, I mean, model of its time, if I talk about, right, containing so many number of parameters and trained on 100 billion tokens, if I talk about, right, that's a massive one, right? If I talk about. So, and we talked about the context window as well, which it talked about in the context, right? And then what I did, if you remember, guys, right, we discussed how it internally looks like, right, on the left-hand side, if I talk about, right? This was what we discussed about yesterday, and we also discussed about what is the difference between hyperparameter and a parameter. What is it, guys? Can anybody tell me? Yesterday we discussed what is the difference between parameter and hyperparameter. And not to be said by Aziz sir, because Aziz sir said it rightly yesterday. So anyone else would like to give a thought about it?
Hyperparameters can be auto-updated by the machine, but
hyperparameters.
Yes, yes,
Okay.
yes.
Okay, sir.
Right.
And parameters are manually given, is it, sir?
Yeah. Like based on us, like what we.
Okay. Based on what we talked about. Anyone else? Thank you, Aman sir.
Okay, I'll give a try. I also get confused every time about this.
Okay, sir.
Parameter is the one which gets the weights, like weights which get trained when the model is running. So which gets learned, and hyperparameter is something which we give before we give the set of parameters which we give to the model, so that like a before. Is it right? Or is it ulta?
Brilliantly said. Yes, sir. Exactly. Aman, sir, I think whatever you said, sir,
We
just
need some
interchange
technique
it.
to
Yeah.
not
But yesterday I thought
make it opposite. Like,
you
do you have any techniques like to remember it in a way? Because I also get confused when which is hyperparameter and which is parameter. So if you have
Sir,
any technique in your mind to remember that, because I get always confused with both of these.
Okay. So let me tell you a very simple technique here. Sir, just, I mean, this is what I just came up in my mind. Okay. Here's the thing, sir. I told you that GPT-3 is how many parameter model? You remember? Anyone? How many parameters are there in GPT-3? I told you about.
12,000.
Sir, one. Yeah. So it is close to about 175 billion parameters. That is 175 into 10 to the power of 9 parameters. Okay. And I'm using the word parameter here. Okay. You might have seen all the large language models, right? आपने देखा होगा हम उसमें word use करते हैं parameter. Okay. We never use the word saying that 175 into 10 to the power of 9 hyper parameters. We don't say that it is filled with hyper parameter, if I talk about, right? Because in the context here, and just like that, if I talk about, right, these are the numbers which can be learned. Okay, these are the numbers which can be learned in the context there, right? If I talk about, right, during the time of training, not during the time of inference, right? During the time of training, these gets learned, if I talk about, right? But in the context of a hyperparameter, imagine if you had these many number of hyperparameters to tune, right? That would be I mean, you can't even imagine the number of. Okay, let me tell you. Let me give you an
Our whole
example
life
here.
will be writing the code of giving
Yeah,
all that.
ex exactly, sir. Just to give you a sample here, just like how sir has mentioned here, right? I told you that what you see here, what is happening? Come on, why is it getting serious? Let me uh, off again and let me run it again. Yeah. Yeah. So, guys, if you talk about, right, I told you maximum sequence length T is one of the hyperparameter. Okay. Now, now you are experiment. Suppose you have 10 to the power of 9 billion parameters, and out of which, let's say 10,000, not even, I mean, forget about 10,000. There are 10 of these. Okay. You are saying that let's take one of the, I mean, sequence length as 100, the second one as 1024, maybe third one as 2048, maybe fourth one as 4096. You're experimenting with the hyperparameters. Let's say only 10 hyperparameters. Then you run the entire network of 175 billion parameters, which is taking itself. Yesterday, I told you about the time it is taking, like 3 days. You just to tune one of this hyperparameter, you would take 30 days to talk about it in the context of it, right? You can in theory do that, right? But I mean, that's why, that's why these are called as by design choice. You will use in many of the research papers, guys, right? You'll see the words saying that it is a design choice that they have taken 1024 as the context window. Larger models nowadays, which they have, right? They are probably having like 8K as the context window, right? If I talk about, right? That is a design choice, because if they spend their life doing this, and this was just one of the hyperparameters, okay? If I talk about, right, there are others which are gonna contribute to all of these things. If I talk about, and by the time you finish off the entire training, just to make things perfect, right, you would have realized that you have spent like 100 like 1000 years on this planet, right? And then you might have like the son and son 10 generations are just training it up, and then, so I think you can understand the impact which hyperparameters have. That's why they are called as hyperparameters. You fix them up, right? You find the, obviously you experiment it, right? But you don't experiment those with a bigger corpus. Okay, so what they do generally, the idea here is, right, you take a small batch, maybe small chunks of text, right? See which hyperparameter works best for you, and then you move forward with the context. So you do experiment, but that is by design choice they came up with it. It is possible, very much possible, that whatever the number of token sequences which we are talking about here, right? There could be like 16K. Suppose I'm just giving a imaginary token sequence of 16K length, right? That is way more effective than this. But there is no way to prove that point, okay? Unless you spend those years in terms of obviously, if you have a lot of computation, like yesterday we discussed about the farm which this guy is creating, right? Elon Musk, right? If you have that farm, you can do a lot of what do you say? Experimentation, find out which hyperparameter suits the best as well. Okay, but you have to have that capacity of things to be done in parallel, right? But if you think that okay, मैं एक एक phase को एक एक बार run करके फिर से मैं उसको वो करूंगा, then you are gone for as a matter of fact, in the will be all in bonkers if I talk about, right? So other sir, I mean, it was not exactly a way to remember it, but I think if you relate to these two terms that way, right, they might give you some light as to when to say parameter versus when to say hyperparameter.
Yes, I
Um,
got it. Got it. This is a good way to remember. They say always parameters, and you can remember like that. Yeah.
Yeah, exactly. Perfect. Nice. All right, guys. So yesterday, I think more or less everyone understood the context here. We discussed about how it would look like if you try to train one of these machines, right? But this was the oldest one, right? If I talk about when it all started, still took 3 days if you take the best of the best stuff, right? But then again, if I talk about right. Now, let's move to the next, guys. Okay. So actually, in the context here, this slide was actually about how many basically are in there in the brain. And by the way, when I say the brain, right, if I talk about, right, guys, yeah, one interesting question I had, right? Uh, uh, where does what do you think? You saw the entire big Transformers architecture, right? What do you feel that where is the memory getting captured in the Transformer? You saw different layers, right? You had that attention layer, you have neural network layer, you have normalization layers, and you have many different things, and then repetitive several hundreds of times, right? If I talk about, right, then I mean, whatever it is learning, right? Where do you think these things are? But first of all, my first question is, do you think that it is getting stored somewhere in the transformers? Second question is, if you think yes, then where is it getting stored? What do you think? What is your thought about it? I just want to uh, get an understanding of what you think about it. Did you get the question, everyone? Is the question understandable? I'm not sure whether I'm able to uh, say it properly or not, but is it understandable? Did we all get it? Uh, are we all there? Everyone
Yeah, we
set
got
up?
it, sir.
Yeah. Okay, sir.
So
So you
basically,
understood the
like
question.
LSTM and an RLNs, they have separate memory like that. We do not have in transformers, is uh, what I
Uh-huh.
believe. But
Okay.
like when we learned all these encoders and decoders, when you and Aditya sir taught us,
Right.
so
Yeah.
basically we have learned that the encoders, whatever the output of the encoder, that
Mhm.
itself kind of serves as a memory, which the decoder is attending. Um,
Attending to. Okay.
yeah, so
Awesome. Okay.
it is like that. So in architecture, especially, they have specifically they have not mentioned any memory space or something.
Right. Right.
This,
Exactly. Exactly. Awesome.
so I think it's like
Nicely.
memory is distributed. Um,
Huh.
Even in the self attention, also when we do uh, what self attention does is it basically every token looks into all other it looks into all other tokens, right?
Right.
So um, I think it's like that. I feel, yeah.
Awesome.
And we have
Nicely
something
said.
known as
Yeah.
residual layers also. So
Huh. Yes. Yes. Yes.
so
Residual
yeah, so it
layers.
goes. I've read it recently in like there is a guy who they were not very sure what this residual layers and the backward things which are happening, and they
Huh.
tried it because even now they are not sure. The architecture doesn't mention what does this
Exactly.
backward go. So they tried it
Exactly.
without doing it, and it was not giving good answers. In one
Huh.
Reddit article I had read this about. So
Awesome,
yeah.
sir. Very nicely said. Yes. Yes, sir. You are right about it. Like, frankly speaking, guys, very nicely said. There is, as such, if I talk about, right, I mean, this topic, right, the word writing here as brain is a bit controversial, right, if I talk about, right, but, we as humans, we try to stick up to something which we can form, right, which we can see. Like, for example, obviously, even when it comes to, let's say, obviously, in our Hindu scriptures, right, you all agree, right, that we actually God is someone who is formless, right? So, but we try to picturize that he has some two legs or two hands or maybe a head, and how would Shiv look like, or Shivji would how would he look like, or Hanuman how would he look like, right? So although obviously these guys were from history and they came and they walked the earth, right? A few of it, but the actual essence of God is like formless, formless form of energy, if I talk about, right? So, but then again, as humans, we try to have that picture, right? And then we see it, and then we probably use our hands to, I mean, what do you say? Give our respects to them, because when things become, because we are very much limited to the three-dimensional perspective of the thing, but obviously whatever is three-dimensional, I mean, the things like dark matter exist in the universe, in the outer space, if I talk about, which is by default, if I talk about, right, has no, I mean, if you try to measure those things in the measuring scale which we created, right, you won't be able to do that. But still, they are the ones who are actually responsible for 98% of what is filled in the universe, right? Apart from the things which we see like cups, glasses, or matter, which we call it as regular matter, if I talk about, right? The idea here is very simple, that we want to make it form. We want to make, what do you say? We want to make it in a context-based form, if I talk about. And that is why even whatever I'm going to say here next is still skeptical, but the whole idea here is, right, the idea why you need these neurons, right? You saw this particular network earlier, right, where I discussed about, right, after the multi-head self-attention, you have these guys here, right, the feed forward network or the neurons, right, which in the context here act as brains which retain memories or chunks from what it has learned from. But obviously, as also described particularly by others sir here, right, that is again skeptical, because it is not like, suppose I say the word, suppose in its training, suppose it came with the sentence saying that Virat Kohli plays cricket and he is part of the Indian cricket team. Okay, you have that big line. Okay, so it's not that each of the words are stored in the neurons as exact words, but some context of it is retained in those neuron network, right? You can still think of it, because if you, I told you, right, we try to play it safe, but doesn't mean that it is actually the case. But for our understanding, we can think of it as, right, Virat Kohli, there would be like, obviously, what would be the work for these self-attention guys, right? So they will be taking those Virat and Kohli, and maybe there's the word cricket, right? So they are all interacting with each other in the context there, right? If I talk about, but you saw that Virat Kohli is way more separated out than the word cricket, right? It comes afterwards, right? So if I talk about, although it will have some contextual, because these vectors are, or these matrices are actually interacting with each other during the time of headed self-attention, right? So obviously each of them is affected. Each of the word is being, or I should say, token is being affected by each of the neighboring tokens. That is definitely the case. So the numbers themselves are getting modulated or tuned up. But more abstractly, if I talk about where, suppose there is the Virat Kohli direction in space, if I talk about, right, that has to be attached to something called as, let's say, the cricket direction, because Virat Kohli is associated with cricket, right? So that kind of memory, if I talk about, right, that kind of association is further taken care by this guy here, the feed forward neural network, which is there to check in place. But as I said, these are all vivid memories. Okay, they are not exactly like what we just discussed about. Like there will be a vector called Virat, there will be a vector called Kohli, and then the combined direction is being somewhere tilted towards the cricket direction and stuff. The process which is internally happening is through these ANN, which is, or the feed forward neural network in the context which we are talking about here, right? I hope that particularly makes sense to everyone, right? And that is what we are talking about here, right? So inside the brain, which is nothing but the projection tower, if I'm just fancifully we are talking about here, right? Inside the brain. And when I say brain, what I mean by that is that FFNN. Is it clear for everyone? सबको समझ में आ रहा है? Yes, no, maybe. These are the memory units because you see those, what do you say? Um, um, neurons, basically, which act as the retention memory in the context there, if I talk about, right? But the purpose of the neurons is not to, exactly map out things which you see here, right? They are so rich in context that somewhere in their what do you say, non-feasible gray memory, they have that context attached to it. Yes or no? Guys, everyone, is it clear for everyone? Yes, no, maybe. Or would you like me to give one more simple example? I can even talk about the state of dreams, guys, right? You might have seen that when we all dream, right? If I talk about, right, you might have seen that suppose you close your eyes, right? And I ask you, after you close your eyes, right? I want you, because you see that the space, right? When you close your eyes, right? You see that you know that the circumference of this head or the sphere which we have here, right, is limited, right? If you talk about the dimensions are limited, right? So if you talk about, everyone has that limited space, right? Now, if I talk about, right, I ask you that close your eyes. If it is limited, go to the boundary where you see the head's boundary. Can you do that? Will you be? Did you get my context here? I'm not sure. Others, sir, make sense? Does it? Anyone else? Does it make sense to everyone? What I'm talking about here? Yes, no, maybe. Guys, are we there? Are we there, guys? Anyone? Yes, no,
Yes.
maybe. Okay,
Yeah.
perfect. So, yeah. Okay, sir. So that's, I hope, I just want you to try out that experiment, right? Try to go as far as possible after closing the eyes. See if you can reach the end of the head. This is the end of the head, if I talk about, right? Obviously, that you will, you can literally create inside this space, you can literally create the entire Milky Way galaxy from its original dimension, still fail to reach the end of it. What I mean to say. But the idea here is you are able to picturize those things in a very complex space, right? But it still is within the physical space which is there in the head, if I talk about, right? That is what I'm trying to trigger here, right? So you see that the proportion of the head is can easily be seen, right? In this case, I'm putting numbers, right? When I say those head dimension, same way I'm putting numbers here, right? I think you can understand. Everyone is safe to. It is. I hope everyone is able to understand that you. I hope everyone is clear that this input vector, when I write this, right? These are after when you do the attention step. You got it? STEP. I'm sorry. Okay, so I hope you can understand after the attention, right? If I talk about, you wind up getting 1 cross 12,288 as the input vector, if I talk about, right? Which are now going to enter into the, what do you say, the next phase of the things, which is basically nothing but the next, what do you say, and they are going to enter into the FFNN in the context here, right? If I talk about, right? Now, by the way, you can see that there's a number like 12K, if I talk about, right? You know, these 12K, if I talk about, right? There is a interesting pattern, right? I told you that the total, in fact, that was also iterated by Aditya sir, right? When he talked about the GPT-3 model in his lectures, if I talk about, right? that there are a total of 96 layers. Okay, in GPT-3, if I talk about, there are a total of 96 layers. Okay, also this number 96 becomes consistent overall as well. There are also again a total of 96 heads as well for each layer. Okay, you get it, right? And the output from each of these 96 ones, right, if I talk about, right, and you remember, right, I told you that the QKV matrices, if I talk about, right, you remember, right, I told you that initially when you started off with the vocabulary, right, it existed in 12K dimensions, right, 12, the same number, right, 12 to 88. Okay, initially when you start off, right, then you have query, key, and value matrices, right? If I talk about, and I told you that these matrices are lower dimension matrices. They are of 128. The dimension they exist in is 128. If I talk about, and cross whatever you have, right? So you have 128 cross this 12K, which talks about, right? So in the context here, it goes through that process, right? So it becomes the lower dimension if I talk about, right? So I think, an interesting number. Do you know, if I talk about, can anybody tell me what is the output of this? Do this with the calculator and tell me, guys. Can anybody tell me what is the output for this? Quickly. Use the calculator and tell me that, guys.
$96.
Yes, sir. Exactly. Exactly. I wrote earlier that thank you so much, sir. Each of the transformer block, if I talk about, has 96 heads. Okay, I think you can understand, right? And there are 96 of these transformer layers as well. I will show that to you. You'll get a better picture of it. As of now, just look at it in a theoretical aspect or numbered based aspect. Okay, in due time it will be very interesting to see that. Okay, there are 96 heads in each of the transformer, if I talk about, right? And 96 heads means 96 queries, 96K, and 96 value matrices. Do you get it, right? So if I talk about in the context, right, and they obviously that is hold together one transformer block which we are talking about. And how many such blocks are there? 96 blocks are there. So I think you can understand there is a specific reason why the embedding dimension was taken as 12K, right? And from there is a specific reason why the number of heads are equal to 96. There is the way you make these giant brains to work in sync without having to. That's why you might have talked about, right, in the context here that this makes the things way more organized to look at rather than just vividly putting it across, right? So if I talk about, that's the whole point what we are getting here. Okay, nice. Now, moving forward, you will see any kind of the transformer architecture, not just GPT models. You will see these kind of patterns. These numbers exist because they want to make it block by block so that they can, like, there is nothing like, okay, so that's why these numbers are actually chosen in the context. Now, I think you can all justify this. Okay, it is the input vector. Where the input vector, it is going to the you can see on the right hand side, you have this, right? If I talk about, right? So there's a nice illustration of it, right? If I talk about, right? So you can see that before the beginning of the before it goes through the FFNN process, right? If I talk about, right, you have the input vectors, right? This number is not the embedding dimension, by the way. Okay, this number is simply because after doing that QKV, right, you are getting that 128 dimension, right? But there are 96 heads, right? And that is why you have 96 of them. So that is how this comes up as 12 288. So please do not confuse this with the input vector which is coming from the, I'm sorry, this is called as input vector, but do not confuse it with the input dimension during the time of when the entire process started. This number is coming from this, okay? That there are each, so I think you can understand each of them is represented is in 128 numbers if I talk about, and there are 96 such heads, okay? So I hope you can understand, right? And what you do, you know about, I hope everyone knows now about like how does the neural network work, right? Everyone knows that classic picture of neural network, right? You have that input, right? You have those inputs, right? And they are somewhat tuned to some kind of a hidden state, right? And there is a output, right? If I talk about, right? You have connections from coming from each of these and stuff, right? So there is nothing. So you might be wondering, in this case, in the case of transformer, what is this? This is nothing but this one which we just talked about, okay? 128 cross, so they all align in the same line, okay? And then it goes through the forward pass. Do you get it? Okay. So in fact, there is one FFNN for one particular entire transformer block. There are 96 query matrices, there are 96 value matrices, there is 96 key matrices, but they all go into one FFNN, which is obviously those output is tailored together. So ye jo jitne bhi hain, they all get concatenated. So they go like this, if I talk about, and you make a big vector of this entire thing, which is nothing but containing 12 to 88 numbers. समझ में आया? It is bit complex, but you know, to learn these concepts, guys, what I feel is you should have a imaginative mind to talk about, right? Because if you are able to picturize it, then you know, the best way to visualize the thing is to understand how the things work out in this context, okay? So I hope I was able to make things a little bit clear, right? And obviously deep thinking is necessary. So like myself and Aditya sir, right? Please dream transformers at night, okay? And you will get the huge chunk behind what is going on in this giant playground, which we talked about, right? So more or less, if I talk about, right, now I think we talked about here, right? We have the input vector, which is this, right? Now I think everyone can justifiably say this is nothing but 128 into 60, sorry, 96, right? If I talk about, and that is what this number is, all aligned, okay? You saw that classic neural network picture, right? This acts as the input, right? So these are all those small boxes which you draw, right? Now, the next thing, what you do here is, you can see on the right-hand side, guys, right? It will be easy to see it here, okay? So you have this MLP, right? Or you can talk about, I hope everyone knows, right? What is MLP, guys? What is MLP? Everyone? Quick, guys. Anyone?
Multi-layer perceptron.
Multi-layer
Yeah,
perceptron.
exactly. Perfect. Thanks so much, sirs. Exactly. So it goes through it, right? If I talk about, right? And I think everyone understands one key important thing, right? You might have all seen that whenever we design a neural network, we have the input vector. Forget about transformer for now. Forget about transformer. Whenever we try to design a neural network, you might have seen that classic picture. Let me show you here, right? Let me say diagram of neuron of neural network, or whatever I have written. Please don't mind the spelling. Yeah, this is a very classic picture of the neuron, right? If you might have seen hundreds and thousands of times, right? If I talk about, I think you can understand, it is safe to say that in many of the neurons, you will always see that the hidden layers, right? They will have comparatively more number of neurons because they are actually the processing units, right? Compared to that of the input, right? I think you can understand that this is necessary to understand lot of complex structures which are getting inside. Do you all agree to that? Are we all with me on this on the same page? Everyone? Yes, no, maybe, guys.
Yes.
Everyone?
Yes.
Perfect, perfect,
Yes.
perfect. Thanks so much, sir. Yeah. So the classic neuron picture looks like this, right? Anyone you pick off, right? If I talk about, you see that you have few neurons, few input elements. There are neurons which are more, right? And so forth. It gets zoomed out and stuff if I talk about. But as of now, we are just interested. I mean, this is not a very complex structure. ये जो आप जो ट्रांसफॉर्मर में देखते हो ना, that neuron is not a very complex structure, meaning it does not have a lot of hidden states if I talk about, right? It is just that there is a input which is nothing but you saw that input vector, right, which is going in, right? Then it gets enlarged. These are the what do you say, parameters getting in the context of the enlargement, if I talk about. And then in the context at the end, what is happening is, right, I think you can understand, right? Guys, I hope everyone will be with me if I say this. The dimension of this and the dimension of this should be the same. The dimension of what is coming inside and the dimension what is going outside should be the same. So you have X number of inputs, right? That same dimension should be part of the X number of output, if I talk about in the context here, right? But inside, because you want to have more contextual understanding, I think you can, guys, just imagine the beauty of what do you say, transformers, right? It has already gone through a little bit of a refinement process in those heads, right? It is interacting with every other word, right? Here, after it has given a refined thing, it is undergoing further more refinement. Do you see the beauty of this thing, right? If I talk about, right? So it is like, I mean, you are ensuring that you get the best out of the best in the context here. Is it understandable by everyone, guys, right? So because neural network by themselves, by their simplistic architecture, are easily able to classify the things, right? If I talk about, right? Now, when you give super refined things, right? And then it moves forward with the next set of things you talk about in the context here, right? So, you can picturize it very easily like a convolutional neural network, right? You might have seen in convolutional neural network, you do those giant convolutional operations, right? And then you wind up getting those lines. Like, let's say you are talking about the number 9, right? You take portions of it, right? And those, after undergoing super refinement, is gone through the what do you say? If I talk about in the context of like it goes through the neural network at the end of it, right? If I talk about it, right? So I hope that's particularly clear for everyone. Is it understandable what I'm trying to relate to here? Yes, no, maybe. समझ में आ रहा है सबको? Yes, no. Are we all in there with me? Perfect, sir. Okay. And I think more or less you can all understand, right? There's the what do you say? So it gets gigantified or bada karte hain isko, right? This is also known as up projection. Okay, let me tell you guys. Okay, this process which you talk about, right? ये वाला जो आप process देख रहे हो ना, right? This is referred to as up projection. Okay. Similarly, what could be this, guys? Can anybody tell me? What could be this?
Down.
Yeah, exactly. Down projection. Exactly. Okay. So you make things bigger because you want to furthermore understand the context. It is in this process is where that Virat Kohli plays cricket, or maybe Virat Kohli is a Indian cricket player, right? You have the words Indian, you have the words what do you say, player, and cricket, right? It is in this process because you already have that small reference which is already super refined. इसको हम क्या कर रहे हैं, उसको और बड़ा कर दे रहे हैं. We are trying to make it bigger so that each of this, right, if I show you the lines, it is like this. If I talk about, you can try creating individual lines, okay? If I talk about, right, I mean, I don't know, if I talk about, I think that makes sense to everyone, right? So that's how the things work out, right? So that's how the neural network looks like. And this is the place where it retains. So you cannot say that it is actually retaining individual words. It is retaining, just like how I showed you through an example, that yeah, it is through a vivid example, if I talk about, right? But this is the place where those information get condensed and stored. Everyone understood? Yes, no, maybe, guys? सबको समझ में आया? हाँ, ना?
Yes,
Okay,
yes.
good. Perfect, sir. Now, by the way, you see this, right? You have the output matrix, which is of the same dimension as this input matrix. What is this term, guys? Can anybody tell me what is happening here? Because I think you can all understand the one concept here, which we have been discussing about, right? So it is already having this original info, right? After getting more, what do you say, context about it, right? You are shifting the direction by adding whatever you got out as the output to the original, right? Because I told you, right? The input and the output are of the same dimension, right? If I talk about, so all you can do is easily go ahead and add this up, right? Because this is, if this was, what do you say, E, right? So this becomes, if I talk about in the context, del E or delta E, if I talk about, right? So what you get in the output here is nothing but E plus that del E, okay? I'm not able to draw that symbol here. I can do it like it looks like this. Maybe you can all understand the delta E, right? That small change which it got with, which after it is obviously more refinement to whatever it has learned in its previous steps. Here in the context, it gets those cricket direction. It also gets the idea that it, I mean, Virat Kohli is an Indian and stuff, right? If I talk about, so it goes forth, and maybe in the first step, it only gets the idea of Indian. Then in the first, I told you, right? There are 96 such blocks. Then again, it goes to the next block, right? It gets the context, adds, maybe you can say that it adds cricket to it. I'm just giving you a vivid example. Doesn't mean that it actually happens. Just to give you an example here, is it clear for all of us? सबको समझ में आया कि हो क्या रहा है इधर? Yes, no, maybe. Clear about it? Everyone?
Yes, sir.
Perfect.
Yes,
Thank you
yes.
so much, sir. Awesome. All right. Now to make it more concrete to look at, right? You can see it here, right? If I talk about, right? This is how exactly that MLP block looks like, right? So obviously you want to make it bigger so that it understands and has much more rich contextual meaning to it, right? So you enlarge it. That is the up projection here. You can see here, right? If I talk about, you do that, right? And this is the bias term, by the way. You know, in the entire lecture, we haven't discussed about biases, and very few times, I think, even our Aditya sir might have also talked about biases there, right? But you should understand, guys, that bias is a term which gets added up in every context. There is a bias vector in, what do you say, Q. There is bias for K. There is bias for V. So that's the bias vector, which is of the same original dimension that gets added up in the context. So bias is something which gets added up in all of these contexts, right? So there are few more additional parameters which we talk about that shifts the understanding to that particular for a little bit, so that we understand it much more in a contextual manner, right? So I think you can understand we have the linear transformation here. Then there is obviously, I think you can understand here, right? One kind of an activation, because we are talking about neural networks. Neural networks do not go without activation. If I talk about, So if I talk about it, right, by the way, it is shown in two different matrices. Obviously, it is one of them, happens in one, in the conjunction of each one of them, if I talk about. But you can see here, right, that negative numbers, like we all know about what rectified linear unit does, right? There's this function here, right? Negative numbers tend to get zero weightage, but if I talk about positive ones, they remain as it is. So you can see the number conversions here, right? So negative of 8.9 getting converted to positive of 0, if I talk about, right? So that way you get a super refined structure again, because this thing acts like a gatekeeper, right? If I talk about, right? So so important facts like Virat Kohli tending towards cricket gets added up in this. All the other non-relevant context may get the what do you say activation as 0. I'm just giving you an example, okay, just to understand what these numbers could translate to. Okay, so I think you can understand this is what we talk about in the context of the multi-layer perceptron block, which we see here. Okay, now just to come back to what we were discussing earlier here, right? You see, now I'm going to put these into perspective. By the way, guys, there is one small change, right? In real networks, like if you talk about llama trained networks or GPT networks and stuff, ReLU is not preferably used. Okay, ReLU is not preferably used, and for a very simple reason. And I think Aditya sir might have mentioned it, if I recall it, right? So guys, do you recall why would you not like to use ReLU in these? क्यों नहीं use करें हम ReLU? It is just for the picturization purpose. It shows ReLU here, but that is a little bit misleading when we talk about large language models which have been developed now currently in current standards. If I talk about, क्या लगता है? Why am I saying ReLU not to be preferred? If I talk about, the answer actually lies because of how ReLU looks like. Can you tell me? Anyone?
The
would like
negative
to
values
attempt?
are eliminated by ReLU. So
Exactly. Brilliantly said. Yes, exactly. Negative values are what you say eliminated by ReLU, if I talk about. Okay. So what could be a possible solution, guys? क्या कर सकते हैं हम इसमें? एक और modified version of ReLU exists. क्या होता है वो? हम लोगों ने पढ़ा है, I think.
leaky ReLU.
Yeah, exactly. Sir, it is possible. I wanted you to exactly tell that only, right? So, but let's also discuss about that as well. तो आप सभी ने ये देखा कि यार इसका कलर मैं चेंज कर लेता हूँ. Now, you all saw that ReLU looks like this, right? Meaning all the numbers which are negative are given directly 0, if I talk about, right? But on the other hand, how does leaky ReLU look like? If I talk about, if I draw the stuff, right, you would see leaky ReLU something like this. There will be a small step here, and there is this. Here, you got it, right? So it is basically a straight line, right? But I think you can understand this is some alpha of that stuff, if I talk about, right? So if the original value was -5, right, and alpha value is 0.1, right, then this gets transformed. -5 gets transformed into just 0.5, if I talk about, right, in the context here. Right, if I talk about, that is 1/10 of the original value, right, if I talk about. Similarly, if I have the value as 100, and let's suppose my alpha value is maybe I take 0.01, in that case, again, you can see that it becomes minus, क्या हो गया भाई, ये क्या होगा? I think 0.1. Is it correct? नहीं, 1 होगा ना? Yeah, I think, what is this?
No,
1 by
minus
100.
0.1. Minus 0.1.
Yeah, exactly, sir. So it will be -1. No, sir, -1, sir. I think it will be -1 because -1, right? So yeah, you are giving a gradient. I mean, you are giving a value of -1. Perfectly said, sir. Thank you so much. Awesome. Now, guys, it is possible that we could have taken this because it is at least retaining. And by the way, yeah, one more important question. Why would you like to keep negative values? Yeah, you might be thinking about, right? Negative values are contributing, I mean, nothing. Then why would you like to keep negative values? Anybody would like to, why not make it just make them 0? Why would you like to keep negative values? Because anyways, they're contributing less. Why would you want to use negative values? What do you think, guys? Anybody? आपको नेगेटिव वैल्यूज रखना ही क्यों है? मैं बोल रहा हूं कि रखना जरूरी है. It is important. But why am I saying that? Any ideas, guys? What do you think? Okay, let me say it here, right? If I talk about, right, if I talk about the negative values, right, so there might be some of the vectors, right? जब आप उनको sum करोगे ना, ठीक है? It is possible that the overall thing which you talk about, the overall stuff which you get is overall a negative value, okay? And just because it is a negative value, okay, what you are trying to do is, I mean, you saw that being a transformer model, like containing 175 billion parameters, right? If I talk about, if you remove all the negative values, right, it will completely get rid of the few things which are, I mean, also trivial in this context. Like, for example, the word the, which don't have meaning, but I think you can understand these words are very much important to make a sentence, right? I can write Virat Kohli cricket. You or anyone else in this audience can understand it, right? Virat Kohli India cricket. If I say this and full stop, would you be able to understand what I'm saying here? Yes, no, maybe? As human beings, I think we all can understand, right? About the context, right? Human beings, cricket, what do you say? Virat Kohli, cricket, Indian team, or whatever, right? I say this without taking the complete sentence, right? Yeah, everyone would understand, right? Yes, no, maybe?
Yes. Yes. Yes.
Yeah, exactly, right? Meaning what is the context? Everyone can get it. But obviously, you won't be getting if you try to retain these information and only these information, those which are non-important ones, or maybe not contributing to the actual context of it, get completely nullified. Do you get it? So the meanings like an, on, the, and stuff, which are necessary for sentence construction, they get nullified. Is it understandable by everyone? I'm just giving you a practical example of how and why would you like to have those negative values. Yes, got it? Yes, or no? Right? Yes.
Yes.
Now the
Yes.
problem still persists. Yeah. Now the problem still persists. What is it? That suppose you keep it as what you say, what if it was just a straight line, right, without having these, if I talk about, or in fact I take this leaky relu, right? Now if there are numbers, if you have a very big number, like let's say 100, maybe 14, right, if that was the negative value which you got, right, in that case, suppose your leaky ReLU alpha value is 0.01, in that case, it will still give you a considerably very large value, right? -100, it's going to give you a value considerably bigger value if you talk about in the context, right? Because leaky ReLU, as it says, right, if you continue in the negative direction, it's going to have that, right? It is also going to increase. By a fraction, I agree. I am not denying that. By a fraction, it is going to increase, but it will still contribute, and you might end up getting larger values which you do not deserve. For, let's say, the word a, let's say the word the. So in that case, if you have more larger values, this entire network will tend to think that, okay, these also have to be given preference, right? And in that case, you wind up getting words like these, a, the, and stuff repetitively without having to, I mean, not retaining the context of what we are discussing about here, right? And that becomes a big challenge. Okay, you got it, right? So you can have, so it is bad to, so moral of the story which I said is, it is bad to omit all the negative values. Also, it is bad to keep something like this in the form of a small gradient, I mean, small step, right, to be kept across like that. Because as the value gets bigger and bigger, the projection also gets bigger, right? So it gets bigger and bigger here as well, right? And that's why the overall contribution it becomes more, right? So in order to avoid all of these stuff, okay, these guys, I mean, the people who, talked about in the context here, they came up with GELU, or Gaussian error linear unit form of non-linearity. Do you get it? It is it is neither ReLU is taken, nor leaky ReLU is taken. And GELU, basically you use GELU. And all of a sudden, why am I taking GELU will make you guys will make sense of it the moment I draw GELU, okay, for you. So GELU actually if I talk about, right, in the context here, somewhat looks like this. There is a kink here, okay, and in fact it is smoother here if I talk about, and it goes through like this. So the kink part here, okay, is what is very important. Do you get it, guys? This is what, or in fact, it is known as Gaussian, right? Error linear unit, okay? GELU. So they came up with this because now I think you can all understand, thanks to this kink, okay, if I talk about, right, all the bigger numbers, right, even if you have very large numbers, right, they are, in fact, if you talk about, right, it depends on the scale which you are talking about. So if it is a very big scale, it is, again, you can see about the context here, right, in the even if, can you see this? Suppose there was this number 100 here and there is number 150, you will see that the number 150, if I talk about, right, because of this there is a peak here, right, you will see that 150 will be represented with a relatively smaller number than that of the peak which you see across it. Do you get it, guys? Is it understandable? So they came up with the idea of having a non-linearity, having non-linearity through GELU. Now, even bigger numbers, bigger negative numbers will circle around this. Okay, they will be contributing, but it will say, bhai, tera contribution bas itna hi hai. Just go to this. I mean, you have your own contribution to some extent, right? And then what you do is basically cut that off. समझ में आया सबको? Yes, no, maybe?
Yes, Soumya.
Perfect, sir. You others, are we all getting it, guys? समझ में आ रहा है सबको? I think this is the easiest possible way I can explain it. Is it understandable by everyone?
Yes, sir.
Perfect. That's great, sir. So they came up with the idea of GELU, right? So when you talk about this Gaussian error linear unit, if I talk about, because of this, and there is a smooth transition here, by the way, okay? There is a smooth transition at the, on contrast, if I talk about ReLU, you talk about in the context of this, right? I mean, there is a sharp edge here, right? But here you have a nice transition. It is actually like this. I mean, यार इससे बढ़िया तुम्हें ड्रॉ करते हुए ना दिखा के, it would have been better. मैं आपको यही दिखा देता हूँ. So what is it? GELU. Sorry. GELU. If I talk about, let me show you here. You can see here, guys. Okay. So the GELU looks somewhat like this. So bigger numbers still have some say to it, okay, if I talk about, right, and if I look into it, right, depending on the context, right, it goes through the entire case. समझ में आ गया सबको? Yes, no, maybe? Correct. So ये है इसका advantage, okay, you don't put that entire thing across, okay. So now, perfect, that's great. So अब बात ये है, let's come back to our projection tower. Okay, I have the input vector right now. I think you can understand this is little bit misleading. Okay, the MLP block. This is actually GALU. Okay, which should be passing through here. Okay, that's the only thing. But the overall concept remains the same. Okay. So let's move forward here. Okay. So I have this right input vector, which is so and so forth, right? I make it, I mean, I multiply it using the up projection. If I talk about, right, you have a larger projection matrix, right, which is of that embedding dimension multiplied by, you might be thinking about this number here, guys. Okay. Guys, what do you think? This is a random number again? Did you get the question? Is this a random number? What do you think, guys? One? Anyone? Guys, just give it a try. I mean, obviously, we are all learning, right? So, what do you think?
I think it is the random number.
A random number. Okay, sir. Okay. Okay, sir. If it is a random number, just I want you.
I think
Yeah,
it is
sir.
something not related to.
It is something. Sorry, sir. I didn't get you, sir.
I think it's not a random number, sir. Is it so?
Okay. Yeah, it is not a random number.
So, like,
Yeah.
am I right or wrong? Like,
Yeah, actually, you are right about it, sir. Okay. So you saw that there is this, everyone remembers this number, right? This is the dimension in which things exist, right? I wrote this number. I also wrote a number 96, which is, you saw that it was part of this, right? And I wrote a number as 128, right? Which you divide these two, you get this number, right? 96, if I talk about, right? Now, if I look into it, right? Just do this, guys. Take this number, okay, and divide it by this.
4.
So 49. Yeah, exactly. Exactly. Thank you so
same
much,
number.
sir. Yeah. So if you do this, you get 4, right? So this projection matrix is deliberately again made in such a way that it is 4 times that of the what do you say, original matrix which we started off with. So you will never see numbers which you won't be able to interpret in the transformer block, by the way. Okay, so that is how the things work out, and that's what makes it a really what you say fun to play around with, right? So parallelism, I told you, right? Imagine this, guys, that you have separate GPU components, okay, separate GPUs, right? And you want to assign tasks to each of the GPU, right? So it is very easily parallelizable because the numbers are so interestingly denoted that, okay, tu आधा ले ले भाई, मैं आधा ले लेता हूँ, right? If I talk about, right? So I have 96 layers, right? If I talk about 48, I think 96 divided by 2 is 48 only, right? हाँ, 48 and 48. अगर हमारे पास 2 GPU है, वो बोलेगा कि workload divide करने के लिए, you take 48 of them, 48 of the heads, I'll take 48 of the heads. So you see that massive parallelization is possible thanks to the way they have created it. Okay, and these are not random numbers if you talk about. And now I think now you are able, since you are able to understand the blueprint of how these transformer architecture is getting created, right? When you design your own transformer architecture, suppose you create your own transformer. At that time, you can think of it like, okay, let me make it parallelizable. So let me take numbers in such a manner that these are so much so divided in the context here, right? If I talk about, right? So that's the whole idea behind what we are talking about here, okay? So I think that's fair to understand now, okay? So you see that up projection matrix, okay? Because I think you can understand what is the input dimension? 1 cross 12K, okay? What is the up projection matrix? That is 12K rows and 49K. So I think you can understand, right? If I talk about, right, this pretty much, if I talk about, this has one row, okay? And it has 12K columns, if I talk about, right? You don't, I mean, just to denote it, okay, doesn't have to be, you can also interchange it, doesn't matter, right? But here's the part here, right? You have number of rows in this context, right? If I talk about, that is 12K. And here you have, again, if I talk about the number of columns is, if I say 49K, right? In the context here, right? If I talk about, right? Now, can you tell me when I do the matrix multiplication of these two, what do I get, guys? So you have 1 comma 12K and you have 12K comma 49K. What do you get? What matrix shape do you get, guys? What is the shape of the matrix? Yes, exactly. Brilliantly said, sir. 1 comma, yeah, exactly. 1 comma 49K. Exactly. Thank you so much, sir. Brilliantly said. And that is exactly what you will see the next step. Can you see this here? The expanded vector is of the dimension of 1 comma 49K, or whatever we have talked about in the context here, right? Got it? And that is this 1 comma 49K is the middle layer which you saw here, right? There are 49K representations, right? If I talk about, and each of them goes into the context of describing the same, okay? If I talk about, right? Now, I hope you can understand after it has interacted, okay, this vector, again, now what happens is, let me just close this off, okay? Now, I have GALU, I add non-linearity to it, okay? If I talk about in the context, right? So if you look into the context here, right? Because all of these vectors, right? They have to, like, all those which are very close to, I mean, sorry, those which are negative, they become like, they get their things chopped off, right? Because of this GALU non-linearity, right? And post this, you have you have another matrix, if you talk about, which is nothing but the down projection matrix, right? If I talk about, right? You saw that earlier you used up projection, which was 12K into 49, okay? On the other hand, you see that this is the opposite. You see the complete opposite. Why? Because now you want to, after you have done a lot of understanding, like 49K values, you have done a lot of understanding. Now you want to compress those 49K values to 12K values. So आप क्या करोगे? आपके पास ये vector है, you have 1 cross 49K, and you have the down projection matrix, which is of size 49K cross 12K. What will be the output matrix size, guys? Can anybody tell me? After this interaction, what will be the output matrix size? आप लोगों को थोड़ा दिखाने के लिए, let me do this. Yeah, I have this vector, right? There is the down projection matrix, okay? And in इसका ऑपरेशन होने के बाद आपके पास क्या बचेगा? Can you tell me?
1 comma 12 28
Yes.
8K.
Exactly, sir. Brilliantly said. The output vector now contains 1 cross 12K vectors, just like the same dimension as this. But it is super refined. Okay, you are maintaining everything. Okay, but it has gone through these extensive cleansing process. Okay, what you can call it, and then it comes up as the same. What do you say, in the same vector space as this. सबको ये चीज समझ में आया? Yes, no, maybe, guys. ये हो क्या रहा है, क्यों हो रहा है? Yes. Perfect. Thank you so much, sir. All right. Now that we guys all understand this, right? So now we are going to talk about, right? I have already told you about this, right? This dimensional dance, right? Whatever you see here, a funny name, right? dimensional dance is repeated across 96 different transformers layer, right? And with a total of 175 billion parameters, which enables the GPT-3 to store, process, and generate in astonishing human-like ways. Do you get it, guys? Okay. This is what we just talked about, right? I think more or less you saw, right? So GPT-3, it actually proved, I mean, just like last time we discussed about, right? Just scaling can do a lot of things, guys. Okay. I mean, you don't even have to do a lot of computation. I mean, माथा ज़्यादा use करने का इसमें ज़रूरत नहीं है. And that is why, guys, I would, that is the reason, you know, the current level of research which goes on in the industry is about, you know, it is good that we created our transformers, right? We created transformers in different ways and stuff, right? It is good about that. But if you look into it, guys, right? I mean, it has retained so much of the memory, you know, many of the layers are just idle, by the way, okay? And that becomes problematic, okay? I mean, I think you can understand. That is why you are not proving the point that how you can design efficiently. This is not an efficient design, but this is a complete design, if I talk about, okay? So efficient design would be that you take, maybe it is possible that you don't even need 175 billion parameters. And you know, true to that fact, there is one I don't recall that perfectly, but that was actually part of our Chelsea, I think, Chelsea paper. Is it Chelsea or Chelsea paper? I don't know. Chelsea paper about, I don't know, it is called Chelsea, number of parameters. Chinchilla. Okay, it is Chinchilla paper, by the way. I'm sorry. I don't know what's the spelling. Very Chinchilla paper. Yeah. Okay. Yeah. You know, this is one of the what do you say? Papers, right, which actually talked about that whatever the large language models which we have currently, right, you see, right, that you can see here, right, if you talk about, right, same computation budget at this and 4 times more data, right, these are not efficient. If you talk about, right, Chinchilla paper, if I talk about this particular paper, yeah. Let me see if I can find the graph which they talked about here. Chinchilla 70p. Trading tokens. You know, let me tell you what I mean to tell you about about this paper specifically, guys. Okay, I mean, this was not part of it. I just came up with it because I mean, I didn't think of discussing it about here. Okay, but it came here because you see the word scaling alone, right? If I talk about, right, and that's why I wanted to focus on it. This particular paper, right, says that many of the models, right, are not efficiently built, meaning you don't need that many number of what you say parameters. Like for example, GPT-3 containing 175 billion parameters, you don't need that many number of parameters to what you say train that I mean to efficiently train that many number of tokens. Like for example, can you see this here, guys? Okay, look at this. For Chinchilla paper, you can see the number of parameters they used is only 70 billion. Okay, look at this. They used only 70 billion parameters, but they were able to train 1.4 trillion. That is, in fact, if I say 4 to 5 times more than that of the number of parameters which GPT-3 is requiring. Do you get it, guys? Meaning the models are not efficient enough. You don't need that many parameters. What they proved as the point, right? And this paper is considered as the base paper, by the way. To understand if a particular model is optimized enough. Do you get it? Okay. So if I talk about, right, so you see that number of parameters are 175, which, and the training tokens were 300 billion, right? Only a few, okay. But if you talk about it, look at this, right? They have 70 billion. So, over a period of time, they increase the number of parameters, right? You can see they have increased the number of parameters, but they are only able to take that many number of tokens. But Chinchilla proved that 70 billion tokens, like for example, in its own sense, was enough to, if trained properly, right, with some optimized loops. If I talk about, right, you can even train to 4 to 5 times more than that of the training tokens with relatively lesser number of parameters. Did you get the context of this, guys? Meaning, what I mean to say is, moral of the story is, they are giant models, they are good enough, but they are not efficient in the context of it. Meaning, you can do more in the context of the things. Like, for example, right, you can, if I ask you the question that, can you write a prime number program, right? You can run the program from 2 to n minus 1, right? You and go through the entire loop. But that is what you say. No one does it nowadays, right? And a more optimized, and you don't need to go to that iteration. You're wasting a lot of it, right? You're wasting a lot of energy, right? So in that context, right, you can only go till the root of n to find out what all numbers are there, because that way you reduce the number of looping steps as well. Is it understandable, guys, what I'm trying to match here? Same way, you have giant models, but they are not fully optimized in the context of what we are discussing. Yes, no, maybe, guys. समझ में आ रहा है क्या बोल रहा हूँ? Yes, guys, are we there? सब चले गए क्या?
सब लोग लंच पे चले गए लगता है.
Okay. Chalo, sir. Let's take a quick break, maybe. We'll probably be back.
Let's take a break, but yeah.
Okay, sir. तो समझ में आ गया ना सर अभी तक जो whatever I discussed about, right? These are a little
Yes.
bit into the deeper thought about these models, how these things are working, right? But these guys proved that fact, guys. That whatever large models have been created, right? Many of them lack that optimization capability, right? So you see this line here, right? So anything which is you use less number of parameters, right? But you are able to do more calculation. That is what flops is, okay? But you can see that GPT-3 exists here. If it is existing in this line, the Chinchilla paper is the if I talk about in the context of, you can see here, right? If you talk about, right, look at these standards, right? Most of it, right, this is giving the average, right, of many of the ones which are there. But you can see that with lesser number of parameters, right, you are able to gain more calculations that can be done on the context here, right? So that was proved by Chinchilla, and the others are more than that if I talk about. Okay, so guys, let's take a quick break and stuff. And if you want, let me go ahead and share this link for all of you, and let's come back in 12 minutes or 18 minutes, whatever there is. I have set it up. यार ये कहाँ गया? Have to. This is the resource for the Chinchilla paper. Okay, feel free to go through it. And guys, let's take the break. Yeah. So okay. Yeah. For 17 minutes. Let's be back, guys, after that. All right. Hello guys. Uh, am I audible to all of you? Can you hear me?
Yes, Somesh sir.
Okay. Okay. Thank you, sir. Okay. Perfect. 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 So, welcome back everyone to the short break. सब लोग आ गए हैं? Are there anyone left? Look, shall we start off, everyone? Yes. No. आज बड़े सब सुस्त हैं यार, सब लोग गायब हो गए आज. Are others there here? सबको
Yes, sir, you can start.
हाँ सर. राइट. एक्चुअली सर आप तो हैं, मैं देख रहा था others are there, are the others present? चले गए. So all right. Guys, should we wait for few more seconds? Wait करना चाहिए क्या सर? I don't know. मैसेज में पूछ रही क्या? Oh, okay. Rishikesh that says yes, we can start.
Hope
Okay.
all are doing right.
Sorry sir.
Hope all are joined, na? All are joined, na?
मुझे सर पता नहीं सर. I think ऋषिकेश सर आप हैं और जय सर तो हैं.
Chalo, I request everyone to say yes in the chat.
Yeah. Chalo. All right. Thanks so much, sirs. Chaliye sir. Let's begin with the context. So, guys, I think more or less we all understand. अभी जो हम लोगों ने just a few seconds back, what we talked about, I mean, few minutes back, right? We talked about this nice paper called Chinchilla paper. I think, if I talk about, and you see, right, this was actually released by Google DeepMind, if I talk about, right, in the context of it, right? So these guys have, what do you say? Talked about, and this became a foundation, right? So many people refer to it as Chinchilla paper, by the way. Okay, by its because it gained momentum after that. Like within a particular budget, you are trying to create these large language models, right? So the idea was, the key question which they asked is it really necessary that we need so many number of parameters to train these many number of data? That was the idea which they wanted to solve in this, right? So is it necessary? As it if I talk about, right? Or it can be or is it possible that it can be done in lower number of so and so, right? We can achieve the same kind of accuracy metrics given with a considerably less number of parameters, if I talk about, right? So that was the key idea. So the genius minds from what do you say, Google DeepMind, they worked on that, right? So if I talk about in the context, so 1 second, sir. Just give me a second, sir. Chal. Yeah. So that was the most, I mean, that was the agenda behind, right? If I talk about, so you can go through this paper if you want to go ahead and talk about it. Here, the idea was, as I discussed about, right? Now, let's move forward, right? So I think more or less you all understood, right? Why I came to that paper was because scaling alone, if you talk about, right, are large language models good enough for scaling alone and stuff, if I talk about, right? So in that case, yes, they are able to sort out big, large amount of problems, right? If I talk about, but are they efficient? Then that is no, right? Not many of them. So you have to design it efficiently in order to work around with it. Okay. So I think more or less we all understand the context here, right? So you can get the concept behind, right? You have this, right? So input, projection up, gay loop, right? I told you about, right? Projection down matrix. Uh, yeah, projection up and down, yeah, and the output matrix. So I was just bit off there in the context there. Okay, so I think more or less everyone understood, right? That was the agenda behind which I was talking about. Now, guys, let's see the overall breakdown. So this is what I wanted to little bit talk about. Okay, so what is that, right? If I talk about, right, 175 billion parameters, right? That scale of a model or that big of a model, right? I mean, what is it subdivided into? I mean, let's just do a theoretical calculation, right? In the context of how do they add up to that big of a number, right? What is happening behind, right? So you all remember this, right? This paper, right? If I talk about, right, the attention is all you need paper, right? If I talk about, and just for the reference purpose, guys, right? It is always very good to, what do you say, have a reference paper in hand, right? You know, the whole attention, I mean, sorry, the whole key point within this paper, if I talk about, right? Let me just do this that I can see as well. Yeah. So the whole key idea, right? You can see, right? The focus of the paper was attention is all you need, right? If I talk about, right, the paper which the people, again, you can see, right? Google Brain, these guys are, if I talk about, like mostly like the research division at Google, if I talk about in the context, right? This particular paper, if I talk about, right, introduces the attention mechanism and everything, if I talk about, right? And overall perspective behind the context, right? You can see the feed forward network, right, in the context here, right? Embedding and the softmax. This gives an entire structure in case you want to have a look at how things are working around with it, right? You remember that formula which I wrote earlier, right? From my session earlier, right? If I talk about, right, this was this is what it was actually, okay? So the one which they used in the context there, right? So this is the overall scale of the paper. So if you go through the paper, it will be much more warranting to understand what is going on in the context there, and it's a good, nice to read and stuff, right? So now if I talk about, right, my context here is, right, we discussed about attention and everything, right? But the question which we want to ask here, right, you can see here, it says, is it really the attention is all you need, or is it something more, right? If I talk about, right, in the context, let's see, okay, in the context of GPT-3, if I talk about, right? So everyone has an overall idea about what GPT-3 is, right? If I talk about, right? So consistently, if I talk about, it is basically divided into 8 overall heads, guys. Okay. So we have already discussed about each one of those heads, by the way. Okay. So embedding, you have, what do you say? Key, right? Key matrix, query matrix, value matrix. There is the output matrix, by the way. Okay. Where, this value matrix, right? I told you that, if we all recall, there was Adarsh sir, you recall, right? There was in our initial days, we had that nice friendly discussion about square matrix and stuff. Adarsh sir, I think you mentioned it that time, right? आपको याद है sir? Adarsh, thank you.
Yeah.
So we had that giant matrix discussion, right? X comma X, right? If I talk about, right? So just like on those days we discussed about, and I told about, right? Indeed, he was correct about it. It is a square matrix, but the whole idea is this value matrix, the value matrix, agar hum usko dekhen, it would actually look like a square matrix, but हमारे parallelism के लिए we want to make things parallelized, right? तो इसको हम क्या करते थे? I told you that this entire matrix is subdivided into x comma y, if I talk about, right, x comma y, and y comma, if I talk about x, right, in the context of it, right? I think more or less everyone now understands, right? अगर मतलब इन दोनों का multiplication भी अगर मैं करूं, I think you all agree, right? ये अगर x, y का matrix है, और ये y comma x का matrix है, this will result into x comma x matrix, which is nothing but a square matrix, right? I told you about that on those earlier days. The idea is to decompose it, right? But in theory or in practice, if I talk about, I can directly take x comma x matrix, but you saw the advantage of having x comma y and y comma x. Y is relatively a very small number if I talk about, right? Maybe 128, right? If I talk about, and if I talk about that smaller dimension, considering the output numbers which you get, right, in x comma x, if I talk about, right, when you do that, right, you are able to do more what you say calculations per head, right, in the context, rather than just talking about or sticking up to the idea of that, right, if I talk about. And that is why this x tends to be the number which is 12k if I talk about in the context. So just like Adarsh sir mentioned on those days, in those days, if I talk about, it is actually a 12 matrix, but it is 12k, 128 and 128 into 12k if I talk about, and then you do the operation and you get this. So the intermediate representation has much more value compared to directly having that values all together, right? So more or less this explains us the concept there, right? Yeah, so I was talking about, right, you have the embedding matrix, you have the query, key and value matrix. Now the value matrix, for our convenience, is exactly the same dimension as the key or the query matrix. Okay, so I told you, right, the value matrix in the context also is like 128 cross 12k if I talk about, right? Now there is another matrix called the output matrix, because the joint combination of these two guys, right, will result in 12k and 12k. Do you get it? So I think you can understand. Can you tell me the dimension of the output matrix? Can anybody tell me the dimension of the output matrix in the context? I should maybe I'll reverse these numbers. This is pretty obvious. I think I'll reverse these numbers. I'll say 12k, comma 128, right? And can you tell me the dimension of the output matrix? क्या होगा output matrix का dimension? Quick, guys, quick. What do you think? I just elaborated just a second back. What should be? Sorry, sir.
12k, 12k.
No, sir. The output matrix, हाँ, ये जो output matrix है, इसका जो result होगा, मतलब इन दोनों का होने के बाद जो result होगा, सर, वो 12k, 12k होगा. इस result को लाने के लिए, सर, what I'm asking is, हमारा आउटपुट मैट्रिक्स, एक्चुअली आउटपुट थोड़ा अनएम्बिगुअस है, या आउटपुट मैट्रिक्स ये एग्जैक्टली सर, एग्जैक्टली 128, 12k, एग्जैक्टली, यू गॉट इट, राइट? सो इन दोनों का अगर मैं ऑपरेशन करूं, फाइनली आई विल गेट अ आउट. ये जो आउटपुट है, दिस इज नॉट एग्जैक्टली what do you say? It is actually the output matrix if I talk about, right? But not exactly in the form as that. What this actually is, initially when you add it up, that is actually a projection matrix, by the way. Okay, so वो projection matrix को इसको हम लोग you get through these, right? You multiply these two together, and then you wind up getting 12k cross 12k as the final output. Okay, so brilliantly said. Thank you so much, sir. And let's move on, right? Now let's look at the numbers. Okay, yeah, by the way, I talked about, right, 8 key components: embedding, key, query, value, output. Okay, these are the 5. Okay, the rest 3 are up projection, you saw from earlier, right? Projection up matrix, there is projection down matrix, and finally I think you can all it is safe to say that since you are embedding something, ओके, वो क्या कर रहा है, वो नंबर्स में कन्वर्ट कर रहा है, बट आपको तो आउटपुट में नंबर्स आते नहीं है, राइट? यू गेट अ प्रॉपर वर्ड एज अ व्हाट यू से आउटपुट इन द कॉन्टेक्स्ट है, राइट? तो हमें क्या करना चाहिए, आखिरी क्या होना चाहिए हमारा लेयर? कैन एनीबॉडी टेल मी व्हाट शुड बी द आवर लास्ट लेयर? हमें जब हम when we feed it to transformer, we change from word to the embedded vector and stuff, right? तो हमें आखिरी में क्या करना पड़ेगा? Anybody?
Softmax.
सर सॉफ्ट मैक्स ये सारे प्रोबेबिलिटीज आ गए सर, है ना सर, ये तो हम कर लिए सर, बट मैं ये बोल रहा हूँ सर कि जो आपने एम्बेडिंग करने के लिए सर पहले यू टेक द वर्ड्स राइट एंड देन यू कन्वर्ट इट इनटू द न्यूमेरिक फॉर्मेट, बट हमें आउटपुट में सर क्या जब हम कोई क्वेश्चन टाइप करते हैं तो वो क्या सर टोकन्स भेजता है क्या? नहीं ना सर, वो तो टोकन्स नहीं भेजता ना सर, टोकन नंबर तो नहीं भेजता। हाँ
Not able to decode your question actually properly.
सर यहाँ पर ओके लेट मी probably show it here, ये वाला डायग्राम से थोड़ा क्लियर हो जाएगा। मैं ये बता रहा हूं कि सर आपने यहां पर तो एम्बेड कर दिया, ठीक है, अब ये जो आउटपुट में आ रहा है ये आउटपुट किस फॉर्म में आ रहा है एक्चुअली, आपको एक्चुअली किस फॉर्म में आना चाहिए सर?
Tokens.
हाँ हाँ टोकन सर, ओके इट कम्स इन द फॉर्म ऑफ टोकन्स, बट वो टोकन आईडी होना चाहिए, क्या होना चाहिए सर?
IDs.
टोकन
IDs. Token IDs.
टोकन आईडी सर हमें समझ में आएगा क्या?
Once
नहीं,
again,
तो
it is
remap
नहीं
करना
आएगा
है
ना
ना
सर?
उसे। We need to
हाँ
remap.
हाँ तो उसको सर क्या बोलेंगे, अगर हमने इधर मैपिंग में उसको एम्बेड किया तो वहां हम क्या बोलेंगे उसको सर?
अच्छा, terminology.
हाँ सर, ऑपोजिट क्या हो सकता है?
I
यहाँ
forgot
पर
that word.
मैंने हाँ
Sample.
अरे सर सैंपल तो ले लिए, सब कुछ ले लिया आप सर, प्रोबेबिलिटी सब खत्म हो गया सर, सब हो गया सर, एवरीथिंग इज डन। अब हमने
नहीं,
पहले तो एम्बेड किया था ना सर, तो हम क्या करेंगे आखिरी में, आखिर में क्या करेंगे सर?
that
What
we
is
need
the
to
opposite of embedding? What is the opposite of embedding?
decode.
सर कोड एनकोड का ऑपोजिट होता है डीकोड, एम्बेड का ऑपोजिट क्या होता है सर? अनएम्बेड।
inference.
Vector.
Debugging.
Unexpected.
या सर समटाइम्स सर ये सारी चीजें काफी सिंपल होती है सर। yeah exactly, I mean we saw many words right in the process right, so the overall idea is what you do, अब आपने पहले तो आपने embed किया था, very nicely said by all the effort of everyone right, आपने embed किया है राइट किसी चीज को किसी और फॉर्म में ताकि वो ट्रांसफॉर्मर को समझ में आए राइट। अब ट्रांसफॉर्मर तो दे दिया उसने, अब हमारा काम भी तो मतलब हमें तो समझ में आना चाहिए ना, हमें अगर टोकन आईडी फेंकने लगा तो हम तो गए काम से, मतलब हमें समझ में ही नहीं आएगा क्या बोला उसने राइट। So that is the reason why we have the final layer called as the unembedding layer, right? Which converts token IDs back into the original format of the words, right? So, or tokens, right? If I talk about, right? So I think now, so these are the total 8 components of the entire GPT-3 network, okay? अब हम इसको थोड़ा और अच्छे से समझते हैं, ठीक है? So आपने एम्बेडिंग देखा, ठीक है? सो आई थिंक एवरीवन रिमेंबर्स, तो हमारा एम्बेडिंग डायमेंशन कितना था 12K, मीनिंग वन वर्ड एग्जिस्टिंग और वन टोकन एग्जिस्टिंग इन 12K नंबर ऑफ डायमेंशंस राइट। एंड हमारे टोटल नंबर ऑफ वर्ड्स कितने हैं वोकैबुलरी में 50,000 के आसपास। यू रिमेंबर दैट वी हैव टेकन फॉर, मैंने आपको टोकन बताया था, सो फॉर द केस ऑफ GPT-4 इट विल बी मल्टीप्लाइड बाय 100 122 100 122 I believe, जो हमने नंबर देखा था, I think if I recall correctly, right, approximately that, okay, if I talk about, और उसका जो भी embedding dimension है, I think GPT-4 का embedding dimension is 16,000. You know these guys, क्योंकि उन लोगों को पता चल गया कि people are now experimenting a lot, right? So they have tighter lips around this, right? They don't discuss about it in public कि मतलब हमने कितना पैरामीटर लिया है। GPT-3 थैंकफुली उन्होंने पब्लिक किया था, जो कि गेन्ड अ लॉट ऑफ अटेंशन, ओके। इफ आई टॉक अबाउट GPT-2 का भी हमारे पास वो है, सो वी बट डिकोडिंग GPT-4 राइट, हमारे पास उसके नंबर्स नहीं है क्योंकि दे कीप टाइट लिप्स अराउंड इट, so you can't go about, but overall the architecture is the same. You can use GPT but don't know about even if you, I think if I talk about, right, I mean if I say chat GPT, if I talk about, I think I ask how many parameters are there in this it will be able to answer in GPT-4. If I talk about, I think it will be able to. You can see here, it gives a disclaimer. Okay, OpenAI has not publicly disclosed the number of parameters in GPT-4. Okay, so if I talk about, right, it has, I mean, it just gives you a vague representation. Okay, so it doesn't give you the context here, right? Estimates, you will find it, right? But the whole idea, क्योंकि अगर आपके पास numbers मिल गए, right? Clever people like us will be able to manipulate and maybe recreate it in our surrounding environment. If you ask the right set of questions to the right things, right, you will be able to recreate the entire thing. Okay, so that's the whole point. So they don't keep it. What do you say? Maybe I'll use say search in web. Don't worry about it. I'm just doing that. मैं क्या कर रहा हूँ? Don't ask about it. Yeah, approximately. Even websites भी आपको नहीं देगा. So even if you talk about it in the context, I will tell you about it in due time. But for now, let's talk about it. That what do you say? They are not known, as a matter of fact. Okay. So here's the thing, okay, but thanks for GPT-3, we'll be able to talk about it or decode it, okay. So number of embedding dimensions, आपके पास 12K हैं, right? So उसका vocabulary कितना है? हमने जो बात किया था 50K. Guys, I want you all to keep some, calculator ready for all of you, okay. Can you do this calculation and tell me? Everyone, can you quickly do this calculation and tell me? I hope everyone understood the numbers here, okay. बताओ जल्दी बताओ everyone, what does it come across as?
I think it would be around 7 lakhs.
7 lakhs? Sir, I mean, if you talk about, right, you can see the exact numbers which I've mentioned here, right? If you talk about, right, when you do this calculation around here, right, it is plus, I mean, you can see here, right? If I talk about, I think it is 17 million, or I think if I talk about hundreds, thousand, 10,000, lakh, 10 lakh, crore, I think 1 crore parameters, if I talk about roughly around 2 crores, if I talk about. So these are the number of weights for the vocabulary size. So everything is there in the transformer block. You have those 50,257 blocks, right? And then you have that 12K, right? You multiply them together to get the final number of weights for the embedding layer. So I think, can anybody tell me how many will be there in the unembedding layer, guys? How many should be part of the unembedding layer? What do you think? आपने embed किया, तो unembedding layer में कितने होंगे? What do you think? Any guesses, guys? Anyone? How many parameters will be there in unembedding layer?
It would be same, I guess.
Yes, exactly. बस उसमें numbers अलग होंगे. Meaning you do 50,257 multiplied by 12K. And let's see that if we are correct or not. You can see here, right? 50K is the vocabulary size, okay? And the dimension of the embedding, because you do the reverse process. Embedding अगर आप ऐसे कर रहे हो, unembedding is a reverse process. I think you can understand, right? So 50K multiplied by that number, obviously it is exactly, if I talk about, right? I think in the context here, मेरे पास यहाँ पर, हाँ, यहाँ पर मैंने numbers I think गलत लिखे होंगे. Let's do the calculation, guys. Okay, so मैं calculator ही निकाल लेता हूँ ना. So 6 lakhs or 7 lakhs, I think sir जो बता रहे थे, that would have been possibly correct. So,
like 6 lakhs, no more than that, but
हाँ मतलब हाँ.
Yeah, related to 61, 62.
Yeah. So this number is actually correct, I believe that. Yeah, so this one is wrong here, if I talk about in the context here, right? So let me do this. here. Just give me a moment, guys. 1 second. That number is up to mark here so that we don't have chalo. It's not doing any calculation as such. So I'll just reverse the process. I think, yeah. So yeah, just like how sir and all of us have mentioned here, right? If you talk about, right? So you have the 61 lakh, I think 61 lakhs, right? 1, 10, 100,000.
It would
No,
be
sorry, it was crore. It was a crore,
61
right?
crore, yeah.
60.
We can say 600 lakhs.
Yeah,
600,
exactly, right? Yeah. Huh. So 61 crores. Yeah, if we talk about, right, in the context here, right? So close to if I talk about little more than 60 crores, if I talk about, right? So let's move forward, right? So you all understood embedding versus unembedding. Utne number of weights embedding or unembedding mein hai, right? Now let's move to the next important thing, that is key matrix, right? If you recall, guys, the way I showed it to you, right, in the context, in the very beginning itself, right? मैंने आपको बताया था कि the key query value matrices, in fact, the key query value matrices, all of them have the same dimension in the context, right? So 128 cross 12K, if I talk about, right? So guys, please do not rely on the numbers here. I think you might, if there is problem with the number, maybe just do the calculation on your end as well. Okay. So, anyways, if you do the calculation here, there is 128 cross 12K. If I talk about that, right, in the context, right? Now, what do you do? I told you, right? Each of the transformer block contains number of heads as 96. Okay. And how many such transformer blocks are there in GPT-3? There are 96 transformer blocks. It is a huge farm of transformer blocks, guys, if I talk about, right? So that is why the grand total becomes 128 multiplied by this, multiplied by this and this. If I talk about, you can do the calculation on your own there, guys. Okay. And you roughly end up with, I think you'll exactly end up with this number. Ye number sahi hai kya, sir? Can you let me know? Anybody? Can you do that with the calculator and let me know about it? Jaldi se. 128, 12K, and 96 and 96. Is it roughly equal to this number? Do you see that here? So you enter the 1,000 crore club, by the way, if this is correct. Sahi hai kya? Can anybody confirm it once? There, guys. So guys up. Can you hear me, everyone? Am I audible to all of you?
Very slow. Like your voice
It
is
is
very.
very slow.
Sir, आवाज आ रहा है आपको अभी? Can
It
you
is
hear me?
right. Yeah,
Okay.
your voice is audible.
Okay, sir. So I'll probably keep it here, maybe. I think I'll just have to rotate. Yeah, I'll do that, maybe. Yeah. So I was asking, आप लोगों ने ये calculation किया क्या? Did you guys get, is it roughly equal to this number which is written here? Can anybody confirm that to
Right.
me?
So actually, I shared in chat. You can refer the
Okay.
chat.
Okay,
First one, I
sir.
missed that 128,
That's
and
fine.
the last one is right one.
Awesome, sir. Awesome. That's nice. That's great. Yeah, exactly. Thank you so much, sir. That's great. Thank you so much. So I think, guys, sir has nicely given in, what do you say? This is actually what was needed. He has given in millions and billions format. If you look into, guys, right? So it is 14 billion, right? Yeah, exactly. Jay sir has also given, right, in the context, right? So if you can give it in the billions format, that will be much more easier because we want to get that grand total of 175 billion, right? So, sir, what sir has shared is 14 billion parameters, right? So if I talk about 14 followed by 9 zeros in this context, right? So that's the whole point here. So you see that here, right? For the key matrix, obviously, I told that the query matrix also holds the same kind of an information in the context there. So you have that, right? Just the D of query, if I talk about, right, in the context. And for that, you have the stuff here, right? Then obviously, if I talk about dimension of value matrix, again, the same number, right? Because you're doing the same thing, right? Now, the output matrix, right? I think you can understand, guys, right? The value and the output matrix are clubbed together in the context here. You need 128 cross, guys, just make a note here. For these two things, which you see here, right? 128 cross 12K, and I have this output matrix. From here, we have 12K cross 128 if I talk about in the context here, right? So in the size if I talk about, right? But however, the way you align it, if I talk about in that reference, right? In the way it is aligned in the context, right? So you have this, right, multiplied. I'll go ahead and multiply these two together if I talk about, right? This is actually written in a little bit of a stuff if I talk about, because the end result, if I talk about, right, in the context here, right, which we want to go ahead and talk about in the context, right? So actually here, if I talk about, right, is our 128 matrix getting the whole idea, the overall idea, be taking it as 12K cross 12K in the overall segment of what we are discussing here. Okay, so that's how the calculation runs out if I talk about, right? But however, in the heads, because each of the head does their own work, right? You can talk about it in the context of these two because these two are in the reference, right? So you get 128 cross 128, and this is repeated across 96 times, right? So you get that matrix in the context of it, right? Because of the huge matrix which you talk about, right? So depends on the context which you are looking through, right? So now if I talk about, right, you have the value matrix, you have the output matrix, all of it, you can see, right? Just because the numbers change doesn't mean that the final weights will change for these, right? So they become the same thing if I talk about. So 14 plus 14 plus 14 plus 14. 14 into 4 is how much, guys? 14, 28. 28 plus 28 is what is it, guys? 46, right? Or 56, is it?
56.
Yeah, 56. Yeah, perfect, exactly. So if you look into, guys, right, this sum total contributes to, if I talk about, right, it is 56 billion parameters which are coming through these things. So these are all coming from the attention mechanism which we just discussed about, guys. Okay, and by the way, what was our original number to begin with? 175 billion, right? It is not even nowhere close to this number, right? In fact, if you look into it, right, it is roughly around 1/3 of it, right? If I talk about, yes, can I say that, guys? Almost 1/3. This number is almost like 1/3 of the entire thing, right? Yes, no, maybe, guys. Is it clear to all of us? समझ में आ रहा है
Yes.
सबको? Yes. So this is roughly 1/3 of the overall number, which we just grand total number, which we discussed about. So you might be wondering, where does the 2/3 come from? That comes from our FFNN. That is from the feed forward neural network. Most of the weights of the entire transformers network lie in these two guys. In fact, you saw, right? You remember, right? Just a while ago in this slide, we were discussing about this, right? If I talk about in the context here, right? So the number of neurons. So you do the up projection. For that, you need a matrix, right? You remember, right? 12 cross. You remember this up projection matrix, which we had here, right? Okay. So I think more or less you can relate to it. Okay. So 12K and 49K, you do that. And there is, I told you, right, there is one new FFNN for each of the transformer block. Okay, so complete one FFNN for one. That is why there is no number of heads here, right? There is only number of layers, meaning every, so there you can think of it, the entire transformer network. If this is the entire transformer, right, this is transformer 0, transformer 1, transformer 2, transformer 3, so and so forth. You have transformer 96, and each of these has single, what do you say, each of them has one FFNN. Okay, if I talk about, so for each of them. Okay, but each of these has what you saw, right? You have just saw the key query value matrices and stuff, right? And it has, each of them has 96 heads. Okay, so that's why you have 96 multiplied by 96, if I talk about, right, in the context here which we are describing. Okay, so more or less that's what I wanted to talk about here. That is the up projection matrix which is containing this, it, and number of layers is 96. Guys, can you help me with doing the math for this? Do you see this number there? Just do the complete math here, do a rough estimate, and please provide me in billions format. Okay, I think you want to see this, these are the numbers. I think it is shown here as well, like it is a copy of it, right? Up projection and down projection, they are copies of each other, just that you do the opposite of what you do in up projection. So you can take these numbers. Can you tell me, guys? Are we there? Yes, no, maybe. कोई है? Are we all there? Can you guys hear me? Sir, आप लोग को आवाज आ रहा है मेरा?
Yes, yes, we are here.
Yes.
Okay, perfect. So, yeah. Raja sir has given the numbers. So 57 billion. Thank you so much, sir. I think that is roughly equal to the number which we just described here, right? And in fact, you can see the numbers here. This number, this big giant number, thank you so much, Raja sir. And this giant number obviously gets repeated twice because, as I said, there is a up projection matrix which converts it to a higher dimension, and a down projection matrix which converts it back to the lower dimension, if I talk about, right? So in the context here, you can see that these guys, 57 billion plus 57 billion, and roughly there was how much? I think 28 plus 28, 56, right? Or 56, yeah, I think 56, roughly around that, right? So you can add the grand total, right? You can take these initial numbers, 57, and let me just take the initial numbers. They are all, what you say, numbers in the context, billions, right? If I talk about, I'm just going to do it a rough approximation. 14 plus 14 plus 14 and plus 14, plus 14. You can see it comes to roughly 170 billion parameters, right? If I talk about, I haven't added these numbers yet, right? So you can even add these numbers, and I think more or less you will get that advertised value of 175 billion parameters. Where do they lie? Got it, guys? Is it understandable to everyone, right? So the grand total which we talked about, right? So I think we haven't even talked about some of the few layers, normalization and biases and stuff. You can but they don't add much to it because it is per layer you add up, right? So if you talk about, so the numbers are relatively smaller. So the total numbers from these, the total contribution from these will be probably in lakhs if I talk about, and compare it with billion. So we'll always, I mean, it will be roughly equal to that number which you talked about, right? So I think you can understand the context here. So I think we can safely say we might now be stumbled upon one big realization, right? Attention is only over a third of what you need, right? Everyone agrees to that, right? the context which we just shared with whatever we have discussed about in the conceptualization here. I hope that is understandable by everyone. Is it clear for everyone? Yes, no, maybe, guys? कि ये जो 175 billion है ये आ कहाँ से रहा है and what is happening? Is it clear for all of us?
Yes, yes.
Perfect.
Yes, sir.
Perfect. Thank you so much, sir. Thank you so much. Now, guys, let me show you a very interesting website, okay, called as LLM Visualizer. Okay, I think this is. I told you in my last session, I believe someone asked that when they see transformer, what do they see, right? So I think now you can relate to that, right? What you see in front of you, right? Let me just share this link so that you guys can also get a look at how these things maybe look like in the form of a giant farm, right? If I talk about, right? So if you look into it here, right? So this is a very small one, by the way. This is Nano GPT. You can see it, right? You know, it's very interactable, right? You can see what the process is going on and stuff. And you can zoom in and stuff, right? If you want to go ahead and talk about. We saw the entire Transformers network. If you talk about, right? And by the way, if you look into, this is only a decoder. If I talk about, right, you can see, right, there is no encoder mechanism here, so that is what is getting shown here. Okay, and by the way, there is nothing called as Nano GPT. This is a hypothetical GPT model which has been created for creating on your computer, right? You can do it on your computer, you can create it on your own as well, if you talk about, right? Because how do I know that? It's because this particular stuff, I think it does it tell me here the number of parameters? Yeah, look at this. Can you see the number of parameters of Nano GPT, guys? It shows us here, right? It shows us 85,000 parameters, right? Where compare where you have 1 trillion parameters, or if I talk about, or 175 billion to just over 85,000 parameters. So this is a very small network of that GPT stuff which we talked about, right? And if you look into, guys, look at this very carefully. If I hover over here, can you see things written on the left hand side? It shows me as transformer 0, right? If I talk about, right, in the context. So this particular Nano GPT contains 3 transformers, transformer layer, I believe. You see transformer 1, and there is the next one, the block, the last block, which is nothing but transformer 2, if you talk about, right? I think you can understand the context here, right? Did you get it, guys? Is it understandable? Yes, no, maybe. Yes. So ये वाला चीज आप लोगों को समझ में आया, right? So this is a farm, how it actually looks like, right? It is giant machine. It looks giant, right? I'll show you in a bit. Okay, you see that this one has 3 transformer blocks. Okay, now obviously what were the components of each of the block? You can see here on the left hand side you have few of the what do you say, multi-head causal self-attention mechanism. You have feed forward networks, if I talk about, you can see. And by the way, I think you can see here in the very beginning you have this nice GIF which you see here, right? I took it from there only, right? Which talks about, right? So it's a nice GIF which talked about in the context there, right? So let me. Yes, so you can see here, right? So if I zoom in a little bit here, right, you can see there are, look at this, guys. There are 3, you saw transformer, number of transformer blocks are 3, right? In each of these transformer blocks, you can see here, there is head 0, head 1, and head 2. You got it, right? So 3 heads. Each of the transformer block is containing 3 heads. Okay. Now, under this, perfect, guys, each head, you should understand, contains QKV matrices, right? If I talk about, right? So I think more or less you can understand that what is going on in the context. So there are QKV matrices, if I talk about, right? And there are, I told you that bias terms also get added, right? But look at the size of the bias term. I told you, right? I can add biases and everything, but look at the size of the bias term, compare it with the weights you have, right? They don't even contribute significantly, and that is why we did not add it up there. But in practice, you should add those biases as well, number of biases and stuff, right? If I talk about, so that's the whole point here. You see the KQV matrices, right? If I talk about, right? Now, moving forward, if I talk about, right, you can see this here. There is the projection matrix here, right? Each of the projection which you talk about, or otherwise known as the output matrix, which you saw earlier, okay? So if I talk about, right, and in the context, look at this. So there is the head stuff which we discussed about on top, right? You can see here, right? This entire block is referred to as a self-attention. Can you see this, guys? I think you can see this word here. It shows this entire block from top to down is referred to as the self-attention block. What is this block? This is the, what do you say, FFNN block, which is there in our segment, which we discussed about it in other terms, right? So the MLP block, or the feed-forward neural network block and stuff, right? You have the MLP weights and layer normalization and stuff, and all of those things are part of it. So this, the moment you come to this part, sorry for that. The moment you come to below, if I talk about, right, here, this marks the end of the entire sequence, right? This is the entire first block. Then you go to the second block, if I talk about, right, having self-attention and stuff, if I talk about, right? So, come on. इसको मैं drag नहीं कर पा रहा क्या? I thought it was draggable, but let me, okay, fine. I'll just zoom in here maybe. Come on. Yeah, so you can see, guys, right, that entire thing gets repeated over, right? You have transformer 0, transformer 1, and transformer 2. And at the end, you can see here, right, if I zoom in some of, it is not happening. Guys, are you able to interact with it? Are you able to drag it down and stuff? I'm not sure. At your end?
Yes.
Yeah, I think you can. Yeah, okay, perfect, sir. Thank you so much. Yeah, so I think you can understand the context here. So there's the raw logits and there's the soft max. सबसे नीचे आप देख रहे हो इधर, ठीक है, ये जो सारी चीजें हैं, that goes through the entire process, and there are residual layers which gets added, right? So just like how we talk about, you can talk about in the context, right? These residuals are nothing but which gets added in the context. So whatever you have, right? That is that delta E, which we discussed about, right? E plus delta E, which we did, right? So I think you can understand that get the overall thing after that summation sign gives you the final MLP residual, which you talk about in the context, right? So more or less, guys, I think you guys are able to understand what this nano GPT talks about in the context, right? Now, guys, here's the thing. You saw that this is the scale of nano GPT, right? You can see there are others as well, okay? Let me go to this here, GPT small. Can you see this, guys? Nano GPT, compare it with GPT small size containing these many number of parameters. I think 124 million parameters, right? Look at the size of it, right? If I talk about in the context, right? You have in the context which describes about the GPT-2, right? This was very small. Compare, it's like an ant and stuff. If I talk about, got it? अब GPT-2 को हम कंपेयर करते हैं GPT-2 XL. तो यहाँ पर आपने ये देखा, you saw the GPT-2 में, I mean the GPT-2, but you on the left hand side you'll see that the architecture is pretty straightforward. If I talk about, and you can talk about, look at this, guys. Okay, it has a number of parameters. How many? You can see 1 billion parameters, right? 1.5 billion parameters to talk about, and look at the, it looks like a building, right? I mean multiple buildings together, if I talk about, right? And finally, if I click on GPT-3, look at the scale of it, guys. The scale of GPT-3, I mean, these guys don't even come to it. And look at nano GPT in the picture of GPT-3, if you talk about. And we talked about 96 transformers, right? If I talk about, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiplied by 1, 2, 3, 4, 5, 6, 7, 8. So 12 into 8 is 96. which you get here in the count as well. Is it understandable to everyone? सबको समझ में आया? Clear about it? Okay.
Yes, sir.
Perfect. Perfect. That's great. So, all right. I think, guys, you can play around with that LLM visualizer, right? It will be fun enough to look into how GPT actually looks like when you break it apart, right, in the context, right? So, can have a look at it, right? Now, guys, next thing to talk about is if I look into, right? Guys, you saw that we have now created, what do you say? I hope everyone understands that we have now overall discussed about how things work out in GPT models, right? In elaboration. And I think now, given the context and given everything which we have learned, right, you can now apply the same kind of a step to create or understand other big parameters which are there. Okay, so other big models, giant models, which are there in the wild. If I talk about, right, if I look into, right, so it's just that the architecture differs a bit from each one. I mean, for each one of them, right, they have their own strategies which they implement, but the overall concept or the context remains the same. Okay, is it understandable by everyone, guys? Okay. I hope that's particularly clear for all of us. Okay, perfect. So this what we talk about here, right? These are the beasts before alignment. By the way, one more important thing. After training, you saw that we were in our training phase. You tune those 175 billion parameters, and then you refine them. You come back and stuff. If I talk about in the context, right? It is like a raw model. Okay. So if I talk about in the context, right? So a raw model is like it is also called as a based model, by the way. Okay. So we are going to a little bit play around with the base model if you talk about, right, in the context. By the way, guys, are we all there here, everyone? कोई गायब हो गए हैं क्या? It will be a very interesting playground which we'll look into now in a while. I want everyone's presence. We have Raja sir, we have Jay. Yeah, we have Raja sir, we have Jay sir. We have Aziz sir. I know about that. What about others? Are they all there? Oh, Ankit
Yes,
Pari
yes, we
is
are
also
here.
there. Yeah, Ankit Pari. Yeah. Okay, sir. Okay. So let's move to a very fun part of it. Okay, if I talk about, let's look into a few things. Okay. By the way, I'm talking about these are wild beasts. Okay. When I say wild beasts, these are like lions. Okay. In terms of the scale of a jungle, these things which you have created, they are like wild lions. Okay. And they are not still so refined in the context of what you think how it actually looks like, right? You have to make it refined. And in fact, let's see how. Let's have a first-hand look about how these models actually look like the moment they are picked up from, I mean, just trained and deployed. कि हो गया training, अब इसको deploy कर देते हैं. तो वो कैसा दिखता है after so many epochs, right? तो जैसा हम GPT-2 के ऊपर बात कर रहे थे, after what you say 32,000 epochs, right? How does that particular entire model look like, right? That's what we are going to look into next. Okay. So if I talk about, okay, because that will enable us to understand what is going on and why some other things are necessary, if I talk about, right? Now, let me close this apart. If I talk about it, I don't need these things. I don't need it. It will be a fun part. So some of these sample wild models, if I talk about GPT-2 containing 1.6 billion parameters, and 100 billion tokens on which it is trained on. And if you look into Llama 3.1, another competitor of the GPT series of models, right? If I talk about, but you know, the best thing about Llama is the biggest of the model is kept public. But you know, there is a big catch. And biggest of the model, when I say 405 billion parameter, look at the scale of this guy, right? You saw 175 billion, right? This is 4.405 billion parameters, right? Which was released in 2024, right? Containing these many number of parameters, trained on 15 trillion tokens. I think you can talk about it very safely. You can talk about it. It has been directly trained on that. अरे हमने वो कौन सा वाला चीज बात किया था कौन सा कॉर्पस हाँ in the very first slide I talked about net fine web yeah, it has been directly trained on fine web data set if I talk about, because you remember, right, it contains 15 trillion tokens, right? So it has been trained on that if I talk about, right, in the context, right? Now, by the way, there is something called as knowledge cutoff. What do you understand? What do you think this term means? Anyone would like to give it a try, guys? What does this term mean? Knowledge cutoff, it says December 2023. What does this mean? Any guesses? Anyone would like to give a wild guess? What does this mean? Anyone? Whatever you feel like.
So knowledge cutoff 2023 means after 2023, it will not give any kind of answer, proper answer.
Okay, nicely said, sir.
So
Perfect.
data,
Yeah, Jay, sir.
so data that is trained,
Data
it's up
that
to
provided to LLM is till the December 2023, I think so.
Yes, perfectly said, sir. Very nicely said. Knowledge cutoff for any large language model. You will see knowledge cutoffs for every large language model. That simply means that the knowledge or which it has been trained on existing prior to that date which they mention. Okay, anything prior after to that, right, is not part of the internal training of the data set. If I talk about, okay. So let's look at it. Very nicely said by everyone. Let's look at few more interesting things, right? So we're going to test out these wild models if I talk about, right? So one of the key areas, right, if I talk about, right, let me click on this here, okay. I'll copy this link for all of you and give it to you all here, okay. Yeah, please feel free to click on it. Okay. Now, let me tell you first, give you a little bit of an introduction. What do you see here, right? There's this, what do you say, website called Hyperbolic. Okay. Hyperbolic.ai, you know, these guys are famous GPU providers. I told you, remember, that 80 GB of memory. I mean, it is senseless to buy that just for training your model, and then because you don't need that amount of graphic RAM for playing games, by the way. Okay, even the best of the best games available in open world nowadays can run easily with 4 to 8 gigs of what you say graphic memory, and that too real looking games. And when I say real world, what do you say, where the physics of the game is really I mean realistic to look with realistic physics, if I talk about, right? Now, if I talk about it, right, let me go to this website from Google, okay? Let me go to Hyperbolic AI. Let's go to that, okay? So you can see the affordable AI cloud. So these guys provide GPUs. Okay, so if you look into it, right, in the context, you see on top you see GPUs, right? So if you look into it, let's click on it once. Okay, you have these, right? H100 GPU you saw earlier, right? If you talk about, right, these fine grade GPUs are available for cheaper alternatives in this. I mean, if I talk about in this particular website, right, you can see H100 GPU. They start from 1.5 per hour, $1.5 per hour, if I talk about, right, in the context. And if you talk about our normal RTX GPUs, you can see they are considerably really less. If I talk about the price point is really less. If I talk about, if you want to rent them out, when I say renting them out, meaning you get the dedicated what do you say, GPU for running those large models, right? So you can see that if you are interested enough, right, if you want to really create your own transformers or do some big chunk of a calculation and stuff, if I talk about, right? So that's how you can do that in the context here, okay? So hyperbolic is that provider, okay? But along with this, okay, if I go into, I can go to inference. You see on the website, there is something called as inference, okay? And you can see here, okay, let me go to click on run inference, okay? Inference, you remember, right? Once a particular model is created, okay, they have been deployed and you want to play around with it, okay? So that is the process of inferencing, right? So you can see I think the different models which are available. I just want to see the list of models. Yeah, there is models here. Okay, so I go to models here. Look at this, guys. It offers lot of different models that are hosted. By the way, you don't need GPU to it, right? You can even, what you say, what I have done is created an account. You can see here, guys. Okay, so I have taken, like, it is a $1 stuff credit, which actually I got this for free, by the way. Okay, for the teaching purposes and stuff, I have like I got it for free in the context there. It will ask you for you registering your mobile number. Okay, you can sign up there. Okay, but put your mobile number so that you get a $1 free credit. Okay, so to try out these models. Okay, so the whole point here is you can see many of it, right? You can see DeepSeek hosted Quen model, right? There's Llama here, right? You can see many of it, right? I think GPT series of models are also part of it. You can see, right? So if I talk about GPT, I think GPT में दो ही हैं इधर. OpenAI is open weight model. If I talk about, you can see it here, right? If I talk about, right? So many of the things, right? Along with that, if I talk about Llama, LLAMA, okay? When I type Llama here, okay, there are a few things which come up, by the way. Look at this. Llama 70B. When you see these words, this simply means billion, right? Wherever you see that, okay. If you see M, it's million. Nowadays, you don't have millions one, right? Generally, they are all trained in billions of parameters. So 70 billion parameter. Llama 3, what is talking about? Llama 3.3, this is that one. This is 3.2, having 3 billion parameters. This is 70 billion parameter. Llama 3.1, the biggest and best. Can you see this? Open source AI model trained by Meta. By the way, Llama is from Meta, right? Beating GPT-4o access at most of the benchmarks, right? You can see it was, I mean, it is a real piece of craft, guys, if you talk about in the context there, right? But that's there. But guys, I want you to focus on one word here, okay? There is this one and there is this one as well here. What do you think is the difference between the two? What do you think is the difference between the two? क्या लगता है आपको? Can anybody tell me? What do you think is the difference between the two? What according to you is it? Oh, is there anyone here?
The number of parameters and the tokens difference.
Madam, if you look into it here, it is saying the same number of parameters, and in fact, it is the exact same model. Yeah, if you look.
Same model. Base,
yeah.
Base over there.
It is built on base, and
exactly.
And also the one model is BF16 for this one.
BF. Okay. BF16 also you observed. I'm very happy. BF16 stands for brain floating point, representation of numbers, created by Google Brain team, by the way, for constituting of 16 bits. If I talk about, they created it for the specific purpose of training large language model. So you can take floating point, precision to 32 bits as well. But the fact is, you have very large space which is getting allocated. So the researchers at Google Brain, if I talk about in the context, that it's their brainchild, they created it, right? If I talk about in the context, right? So they created a brain floating point representation of the numbers, which considerably takes that same amount of space as floating FP16. You see FP8 here, floating point. FP stands for floating point, right? So FP16 takes the same space as FP16, but has more flexibility. Okay, so in the context which I'm referring to here. Okay, so if I talk about it, right, you have these Llama models. Llama 3.1, 405. You have Llama 3.1 base. One is base and one is no base. Let me tell you what I mean by that is nothing but, where is it? Yeah, I go to this. You remember, guys, right? I told you that I'm going to, divide my entire series of session, right, into 3 phases. Okay, one is called as the the phase where you talk about pre-training, meaning when you develop these models, that is the pre-training phase. Okay, the one which you see here, the Llama 3.1 405B base, right, is what comes as the output or byproduct or the product of phase 1. Okay, by the end of phase 1, when you talk about, right, what you get as the output is that base model. Do you get it, guys? Okay, then you go to the next phase, which is post training. Okay, the one which you see here, right, this is way more advanced than the base model. We are going to look into it, okay, as examples and stuff. We'll talk about it, and we'll look into those, okay, and we'll realize as to how these contexts work out, okay. So what you see here is the fine-tuned version of the base model, okay. So my intention in this particular session, let me go to this here. You see these these wild models. One is talking about a Llama Playground Brace, which I clicked on and it redirected me to. Can you see this here, guys? The model which is selected for me here is Llama 3.1 405B base model. Okay, everyone clear about it, right? I can alternatively go to this and Llama 3.1 405B model is also there, if I talk about. Okay, so we are going to look into it. Okay, I have on the left, which is a base model, okay, and on the right, which is called as the chat model, meaning how it looks like after you do the tuning. Okay, I hope that's particularly understood.